Hello. I don't think anyone is here yet, but we're doing this again. Hi, can you guys hear me? Hi Pokemon, hi Masan. Great, okay. So I'll probably start actually doing the things that I'm going to be doing in another minute or two to give people a chance to notice that I have started doing this. But yeah, purpose of today's stream is to test whether or not system module reverse engineering is interesting. So I've got a copy of LogManager from a recent firmware, and I'm just gonna reverse it. I mean, ideally this is part of like a series of these where I actually take this reverse engineering and re-implement it for Atmosphere, since I think that would be interesting for people to see the whole process of going from reversing a system module to re-implementing it. Hi, RG. Masan asks DevKit LogManager or production stub LogManager. So if I was doing production stub LogManager, this would be very uninteresting. It's development LogManager so that it can actually have interesting things for us to see. Since we would want a functional LogManager in Atmosphere if I was implementing it, and so it wouldn't make very much sense to be targeting production stub LogManager. What is in your recycle bin? Really good question. Probably dumb shit. Uh, yeah, IDA, it looks like. Nothing interesting. Stuff that I used when setting up the virtual machine. Yeah, no, there's nothing particularly exciting since this is a virtual machine that I set up like 2 weeks ago. Hi, Ave. Okay, it looks like there are some people here. We've given a chance for people to show up, so I will actually get started. So yeah, let's just get started right away. This is a copy of LogManager. I have some scripts that I use for reversing set up here, and I'm just going to go through the whole process of reverse engineering a system module from nothing. I looked at LogManager once last year, but it has been a long while, and so I don't actually remember how most of this works. So this should be actual reverse engineering, unlike Trust Zone, which is just me labeling things that I know by heart. So yeah, first thing to do is just load it into IDA. It'll be just using the script that we made. Auto analyze, and I like to identify NN main before I do anything else. There are a bunch of scripts that I'll run in a second, but the way that I identify NN main, Ognik has some scripts for this, but I just do it by hand because you just click the bottom function in here a bunch of times, and then you'll get to like their C library initialization, which is this function. And it's always either this one or this one that ends up being main. And it's this one. Great. So this is going to be doing a bunch of initialization stuff that we probably care about. And so before doing anything else, it's time to run the first script that I run on these. Hi, Chris. So something that you may or may not have thought about when thinking about these system modules is that they use the same code that is in the SDK binaries that you find in games. Hi, Stuck Pixel. And the difference between these and games is that system modules have code statically linked into them. where games have a separate executable for the SDK code that they use. Hey, dubs. System modules will just have it inside their own binary. But it's the same code, and it's compiled with the same settings, which means the functions have the same machine code. And so forever ago, HTHH wrote the script, hi werewolf. In the script, it's a pair of scripts that he calls pattern code. The first one, make pattern, takes in a game's SDK binary, and it generates a pattern file of all of the functions in the SDK binary. And apply pattern does the inverse, where it takes in a pattern file and the code that you want to apply it to, and it generates a script that we can use in IDA to automatically label anything that's present in the SDK. And so this is a huge help, and it is an enormous time saver. I copied over the relevant pattern for this version of LogManager before starting, but Python apply pattern, and then I have LogManager and 2 directories up, executable main. And so that should start creating this symbols file here. And so I'll give this a second to run, but once it is run, we should just be able to get a bunch of symbols for free. And this works for every system module. It's better for some than others, but it is an enormous time saver in trying to understand what's going on. This usually takes a minute or 3 to run. And Thog says, and the runtime linking daemon in system modules can load other modules. Yes, it can. All of the code that you see in RTLD and SDK in games is present in system modules. Yeah, so this is what the script's output looks like. It's a pair of addresses and function names. And so you just copy all this, get a file, script command, Python, it'll apply everything, and then if I hit F5 to redo this, a bunch of stuff is now labeled. And so that is significantly better. There are alternate approaches to this kind of pattern matching. Some people use this plugin for IDA called Rizzo, which auto-generates stuff. Some people use Flirt, which Masan is mentioning. But the one advantage of this is that it doesn't have false positives. It doesn't get everything that Flirt and Rizzo do, but it doesn't label anything incorrectly. And so I can be entirely confident if a function is labeled that it is what it is. So this is get current thread. So the first thing that LogManager is doing is it's getting the thread and it's changing the priority to 10. And something that you should know about change thread priority is that in system modules, it's not actually changing its priority to 10 directly. There's this base priority that's 28, I think. And so the way that this will actually work for changing thread priority is it will acquire this global lock and it'll call thread manager implementation by horizon change priority, which calls the actual system call svc set thread priority, which this doesn't label because they removed system calls from the SDK binary, with the priority argument plus 28. So the actual priority of the IPC thread is going to be 38, which is something to keep in mind for reimplementation. And I'll set the thread's name to NN LogManager IPC server. It'll initialize its FS session. And this looks like it's initializing some static variable. I bet this is heap initialization, probably. Oh no, it's initializing events. Okay. What is this doing? This is doing nothing. Okay. So this is probably some dead constructor. I'm going to give it the arguments that it had before anyway, because those are probably interesting for understanding what code got stubbed. But I'm guessing this is an object constructor for the object that's at this address. And yeah, StuckPixel asks, so the lowest priority is 28. No, you might think that, but this is actually a signed argument. You can pass in a negative thread priority, and it will give you priorities below 28. But NNOS change thread priority takes in a priority relative to the base of system. Okay, so it initializes this event, and then it calls some function on the event that is generated. Oh, okay. So it's making a new thread, NNLM host target connection service, or socket connection. Okay, so it's creating a new thread to do communications with PC. So Target Manager provides this functionality called HTCS. HTC is host target connection. S stands for sockets. And basically, HTCS is the service that provides a socket-like interface over host target connection. So if your unit is plugged into a PC over USB, you can get this socket-like interface and you can host a service on a port on the PC. And so this is what they use for like a GDB stub in some other module, where they use their service provided on the PC at some port over USB. And this is going to be whatever thread they have for the HTC thread. Yeah, it's going to create a socket, it's going to accept, it's going to call stuff. I'm not going to reverse the host target connection stuff until later, but it's good to know that that's what this is. Then this is going to be calling stuff. Okay, it's going to be spawning more threads, it looks like. And Adebs asks, what version of LM is this? Recent. I'm not sure if it is the most recent one, but it's like circa 8.0. So a really annoying thing that happens with IDA is IDA doesn't recognize that these functions don't return these aborts. So you just have to manually specify no return on them, and then stuff will decompile better. Okay, so this creates another thread, NNLM flush. Okay, it looks like this is, for some reason, interpreting this as data and not as code, so let's fix that. Flush thread. Flush thread is going to be doing stuff with file system services. We can reverse all this later. I am not so interested in reversing what all the threads do immediately. I'd like to see how the IPC interfaces work before we start doing that kind of stuff. And this is IPC server. So at this point, it is done with initialization, and it will not be doing anything more interesting in initialization that we care about. It's just going to be looping this IPC server. So that brings us to the next thing to do, which is see how the IPC server is set up and running. And there's another script that I use for that, which is this. I think this is released as SwipePC redistribution or public or something, but I use this old version that's not as featureful as the one that we released because I edited it. And so this is the SwipePC script. If you run it on the executable, it will generate information about the IPC functionality in here. Looks like there's the Horizon IPC manager and then some other stuff. Okay, so domain does not actually have a virtual call, so this is probably just my automatic virtual table detector being over generous and detecting things that aren't real. But we know LogManager provides 3 service interfaces. Let me pull them up on SwitchBrew. LogManager services. Okay, well that did not get it directly, but it'll be down here. Is it like log services maybe? Yeah, log services. It provides log service, which has one command, open logger. So this is probably actually log service open logger, especially since it says this takes in a process ID and this takes in a process ID. So this is going to be open logger probably. Then there's iLogger, which has log and set destination. So that's probably what this is. And there's log getter, which is start logging, stop logging, and get log, and that is probably what this is. And that'll make sense. This is an input buffer, this is an output buffer, that all totally tracks. Okay. So, let's dive right in. It looks like the script found the function implementation for this, but not the other ones. This also might not actually be the function implementation, because I think it mislabeled this. But who knows? We'll find out. Hopefully it is. We'll just check if it makes sense looking at it. No, that does not look like the function that we want. But that's okay. It doesn't have to be. This is probably inside the actual virtual table for something. Yeah, so this is TMF server domain manager. That's fine. So what do you do when the script doesn't actually tell you where functions are? Well, there's this trick that I like, which is all service objects derive from the same base class, which means that they all share the same first four members of their virtual table. And the fourth function in the virtual table is never actually implemented by any service object that I've seen. And so all service objects share it in their virtual table. And so if we do a cross-reference to it, this should be all of the service object virtual tables in LogManager. And so we will just go down until we find the one that is iLogger. This looks somewhat promising. Let's see. Where is this used? Yes, I believe this. Okay. Let's see. What is this function? Yep. This function. This looks more plausible. Okay. Yeah, I'm going to say that this is iLogger. Masan says, did they start removing vtable symbols for service objects at that point? They did start removing vtable symbols for service objects. They did that in 4.0.0, I think. But the trick of just cross-referencing stuff works fine. Oh, also, Hedgeberg will be around soon, so that is great. It will be good to have Hedge here. So I'm going to say that this is, in fact, an iLogger, or lm iLogger. Git logger, which I think is the name of that service command. Is it? Open logger. Okay. That's fine. This is going to be implementation. The one thing that you learn about service objects is that all of the service objects have an implementation object at +8 and work how you would expect. Okay. It looks to me like this is taking in, this is going to be some handle pointer to take an output handle to. This is going to be probably some configuration argument. So let's see what this is doing. What we expect it to do is to create a new service object and end up returning it to the manager. And so what is it doing, and does that look like what it's doing? A3 is probably the process ID, since we know it takes in a process ID. Thank you for that, Hassan. Say, this is probably this, probably handle, or actually this is gonna be like one of their shared pointers. Oh, shared pointer, since it's returning a service object and not just a handle. Yeah, that's what this looks like. It's gonna get this, it's going to save the new service object to this output, and if there was something there previously, it'll call the destructor and delete the old one. So this is definitely an output shared pointer for the service object. So this is good. This is going to be the constructor for the actual log implementation service object. What is that called? That's, oh, I guess that was iLog service. This is iLogger. That's fine. I can fix that. Hassan says, pedant note. That looks like a unique pointer, not a shared pointer. Pedant note. That's a shared pointer. I have spent a lot of time reversing how Horizon IPC serialization works. And I know factually that that's a shared pointer. And the reason why it's calling the destructor there is because the Horizon stuff only has a possibility for one reference to an input to this function. It actually is a shared pointer. And I know this because other functions can end up calling it, which is its own crazy thing. This will all get handled by more Horizon library code later. This will be logger. It's actually probably logger impl. Okay. Well, that's interesting. It looks like it is doing a whole bunch of stuff here. And that's surprising to me. It looks like it's creating some LogManager detail object, log packet transmitter. It's calling this. Okay. This is a lot more complicated logic than I would have expected here, but that is totally fine. It's going to be this. It's going to be a reference to the parent object. It's passing in this, and there's going to be process ID. I agree it's weird, but the semantics for how that pointer gets treated later is a shared pointer. I guess it might actually be possible that it's a unique pointer there and it gets passed and becomes a shared pointer later in Horizon library code, but it does eventually end up in a shared pointer, and I've always just assumed that it was a shared pointer. Okay, so let's create a struct for the logger implementation object, since we probably want to know what it's accessing when it's accessing things. It looks like, okay, so it's assigning the first keyword of this to be the parent, and then if the parent isn't null, it's calling the first virtual table entry, which is increment reference, because Nintendo does manual reference counting. So this is going to be a shared pointer to the parent. Oh, that's right, Miss Han. At +8 is not actually destructor, it is decrement reference. And so that's calling a decref. Yeah. Chris says, have you managed to get additional information for the patched Nintendo Switch? Do you mean the patched Switch or Mariko? Because the patched Switch is the same as the normal Switch. But that question makes more sense if you're asking about the new Mariko units that have started being sold. But okay, let's view, subviews, local types, structs, logger, simple. Actually, let's do another struct after this, but shared pointer to parent, and looks like a 8-byte process ID. It might be bigger, we'll find out later. And then good habit is struct logger. They'll have a void for the virtual table and the logger implementation as it's impl. All service objects are like this. Great. So let's make this a logger impl. Yeah. Okay. Where is V10? V10 is on the stack. It looks like it is creating this log packet transmitter object on the stack, pushing a log, calling flush. If it fails, doing something else. This is unlock code. That makes sense. Okay. This is some kind of lock mutex. This is some kind of unlock mutex. There's actually probably in the source code that generates this code a scoped lock here, since there's an unlock here, but we can't know that for sure. But if I was re-implementing this, this would end up being a scoped lock. What is this doing? This is getting some object and assigning it to V3. V3 doesn't change, so let's map it to V8. What is this doing? Okay, this is getting some global instance object, which is interesting. What is that doing? Okay, so this is getting some global object, get unknown global object 0, since we don't know what it does. This is constructing the global object and returning a reference to it. And it looks like it is 16 bytes for this object, the first of which is some function, and the second of which starts out as 0. So let's make a new struct for it. Unknown function. And Uleb says you can get the size of the object easily from looking at release in the IPC virtual table. Yeah, probably. I've never bothered doing that, and I'm doing this out of force of habit. So, okay, what did I do wrong here? Probably can't take variable arguments. Let's just make it take void for now. Actually, that's probably the wrong number of arguments, but we can correct it later. Let's undefine this. Let's make this unknown global object 0. G unknown object 0. And function, what arguments does it take? Okay, it looks like it takes 2 arguments. So let's take in 2 arguments. And that will do. I would probably also returns a keyword. Chris says, of the patches, I meant the previous consoles, not the new ones that now come with battery upgrades. Okay, so you did mean patched consoles, isn't just iPatched. I don't understand your question then. The patched consoles are completely identical to unpatched consoles in every respect except for the patches. So that there's not really anything to reverse engineer on them since they are the same. This is probably a mutex release for whatever's being acquired up here. I don't know, it just set something to 0. Okay. Then this is probably a little bigger. This is doing a D word right. Let's make the object a little bigger and say that this is probably part of this object. Okay. Cool. So we've got this unknown object. Oh, not what I wanted to do. I wanted to go back to wherever we were calling this here. V8. It looks like V8 is... Okay, so this is not a process ID. This is going to be a reference count, it must be. If it is locking a mutex and unlocking a mutex and incrementing a variable, that's definitely going to be a reference count. And so now we can call this a mutex. So that's good to know. The function is being passed to this log packet transmitter constructor. Push log session begin. Let's actually do this write stuff to the log packet transmitter object. Gets the current thread, it gets the current ID, and sets head, sets little endian, sets severity. ACK says, can you increase your voice sound a little bit? Yeah, I probably can. 1 second. Okay, that is maybe a little louder for my voice. Maybe. And Masan is right that I can definitely label that as a mutex constructor. Initialize mutex. If it shows up again and it doesn't look like a mutex initializer, we can just change it. So always label things and just change them later if they are wrong, is I find the best way to go about reverse engineering. So this is some kind of object we know. We should probably start creating a log packet transmitter struct, since we'll care about that. So let's get in here. It looks like this is create new struct type. Struct log packet transmitter. I don't think this is going to be quite right, so let's make that a keyword and just call it keyword 0. We can always change it back to what it thought it was later if that's true. But we don't have a type for the log packet header yet, although we should do that. That would definitely be a good idea. So what is A2 to this function? A2 is a pointer to the stack, it looks like, with 27 as the argument. That's interesting. Okay, I'm going to assume that this is some kind of work buffer, and I'm going to assume that this is a size. That makes some amount of sense to me. So let's care buffer for transmitter. B. It's going to be a size. This is a this. This is some function that it's going to end up calling. This is something. This is something. This is a process ID and 2 ones. Okay. so let's label those. This is going to be this, be some kind of buffer, be some kind of buffer size. It's going to be some kind of function. And there was a 0, a 1, a process ID, and then 2 ones. So what gets called here? So these are going to be pointers to the buffer. I'm going to guess that one of them is some head to the buffer and one of them is like a tail to the buffer if this is transmitting stuff, but I'm not sure about that, so I'm not going to label it yet. This is buffer plus buffer size. Okay, so that points into the stack right now, which is probably not what's actually intended, although there is some space on the stack for data, so that might be fine. Plus 0x18. The size passed in here is 0x1b, so let's see. I'm going to guess that these have to do with where in the buffer it's going to write stuff later, but this is whatever the function that it's going to call is. So let's call this its function and see what it's doing. Byte 28 is A9 at 1. So this is 1 where it's being called here, but we don't actually know what it is. This is unknown bool at 28. And then it calls some argument. It calls, sorry, some function with the buffer and the process ID. So what is it doing there? Let's find out. Okay, it's setting the very first word in the buffer to the process ID. Okay, it looks like V9 is this. Where is this? This keyword is buffer. Okay, so this is actually a log packet transmitter. Log. Actually, I can just make this equal to this. That's probably easier. And I might call this buffer start because I think that's what this is. And it looks like this is actually taking in a log packet header, so probably the first pointer is a pointer to the packet header for whatever this is doing. But then I'm going to assume that this is until log packet header set process ID. I'm also going to assume that the size of a log packet header is 0x18 because that would make this make a bunch of sense. So let's try that. Struct. Log packet header. Oh, Masam linked structs in the chat. Do you have actual log packet header structs? Oh, you do. Okay, that's awesome. That is much better than I could have asked for. If you don't mind, then I will use those because there is no point in not using them. Thank you. Let me copy those in from what Masam posted. Struct log packet transmitter base. Thank you, Masam. This is going to be, I'm going to elide the NNLM : because it just seems difficult to deal with. Log packet header, it looks like you had a struct for. I don't need a base there. 64, I prefer keyword over N64, but it's all the same. Let's see, does that work? It does, and then I can make a log packet transmitter just contain a log packet. Oh. Did I misname this? I misnamed this. Wow, that is surprising. That should be fine. And it looks like you also have some enum lmdetail log data chunk key. It looks like it's a bunch of different kinds of packets, but that'll probably come up later, and so we don't need to worry about it immediately. But okay, let's see how this works now. Yeah, that makes a lot of sense. Log packet header. Great. If we take this as taking in a log packet header, yep, that checks out. Set head. You say this takes in a log packet header. Says, okay, I'm not going to call this bits. I'm going to call this flags. Flags makes more sense to me. Ave needs to leave, apparently. See you, Ave. Been nice having you around. Happy you could make it for the first part of this. Okay, it looks like the first bit in this flags variable is whether or not it is a header packet. And is it little endian? It just calls one unconditional, which makes sense. Okay, it's bit 2 in here. If bit 0 is it a head packet? This is it a little endian packet? It's gonna be bit 2. So that's something to keep in mind. Set severity, v12. Let me assign these. Argument 5 is the severity, apparently. So that's good to know. Yep, that checks out. And the verbosity is argument 6. Okay. That all makes sense. That all absolutely makes sense. 28 is this at 1. Okay. What does this actually look like in the struct? Flags attribute aligned to. If I do, does that remove the need for alignment? That might, but I don't think that's actually true. It might be true. We'll find out. I'll look at log packet transmitter base, care field 28. That is taking in whatever the last argument is, which we don't know, but is presumably something. Unknown. Rule 28 is what I called it before, and that's probably as good a name as any. Okay, so we know that this is the severity. So it is severity of 1 and a verbosity of 0. Severity, verbosity, process ID. This is head. This is unknown. But that should be fine. Then it'll call push log session begin. V2 is 1. Okay. What are the arguments here? They are 0, a pointer to this character on the stack, and 1. Interesting. Okay. So what is this actually doing? So let's give this a proper name. Push log session begin. Push log session begin implementation. Okay, this will be this. This is unknown 0. Masan says that is called push data chunk. It's an SDK. Okay, great. Good to know. Yeah. So one of the things about the script that I'm using to label stuff is that it doesn't label everything that's in the SDK, but it also doesn't have any false positives. And I think it's worth it. But if this is push data chunk, that is super great to know. Do we know anything else about push data chunk? Second argument is the log data chunk key from earlier. Okay, I will make that enumeration then that you linked because that is useful. log data chunk key. And you had session begin 0, session end is 1, xlog is 2, line number is 3, file name is 4, function name is 5, module name is 6, the name is 7, drop count is 8. Call it packet drop count. Then add this prefix to everything. What did I fuck up here? Oh, right, this probably doesn't get a semicolon. There we go. This is going to be log data chunk key. Thank you. Yeah, I noticed the semicolon. The other arguments are probably something to push and probably the size of what it's pushing. So let's call this void data and data size. Okay, if log data chunk key is 0 here, that would be session begin, which makes total sense. And it's pushing 1 with size 1, so that's probably saying, yes, we are pushing a session begin message. Okay, this looks like a bunch of logic. Ooh, setTail. What does setTail do? This is bit 1 in these flags. Okay. Good to know. This looks like details of how it's actually implementing the log transmission. And this we can look into more later. We've spent a lot of time not looking at the service function implementations, and the service function implementations are what are most interesting, in my opinion. So we're not going to go deeper into that rabbit hole yet. What does flush do? setTail, I call some function. Let me add the type here. Log packet transmitter. This function on the header, the payload head minus the payload begin. It's probably log packet transmitter, or this is log packet header. Payload size. Yeah, okay, that makes sense. Sun says if it buffer overflows, it transmits packet and resets. That makes sense. Vacurelli says hello, hello. Well, and it'll say set head 0, paste that send log packet. And so, okay, it'll actually call the function that we saved into it earlier. That all absolutely makes sense. Cool. What function is that? It's probably flush implementation. I need implementation understandable. That'll be fine. So I think that's what that called it down here. Send log packet. Okay, let me fix that then. Send log packet implementation. Cool. So that is what all of this function does. And luckily, the next thing that we want to do is we want to actually look at the logger implementation object. And let me make this a logger. And it looks like oh, okay. Looks like there's another value here that it might be able to use. Logger impl. Keyword. X10. Get set to 1 initially. Okay. If we want to look at these service functions for this logger object, we have the virtual table right here. And so we can just go to it directly. And so it has 2 commands, and these will be the 2 command functions. And so let's call this logger impl. And what is the first command? I think it's log. Yeah, okay. Log, and the next one is set destination. What does set destination do? I bet that dword is the destination. That would make sense. Say this is a logger. It's passing in the implementation to this function. Logger impl set destination impl. Okay. It is actually writing it to a global. That's interesting. Log destination. Log destination, probably better. And we know from previous work that the first bit in this is bit flags. The first bit is going to be target manager. The next bit is going to be UART, and the third bit is like UART, but it could do it when the system is sleeping somehow, or the system is going to sleep. Okay, so that is a very simple function. Let's look at log. Okay, something to keep in mind. IPC functions, when deserialized at this top level, if there is a buffer argument input, as there is here, we know that it takes in an input buffer. This will actually be passed to this function as a NN : SF for service framework : CMIF for common message interface framework : buffer and size, or pointer and size, something like that. And so this is going to be the actual buffer that was passed in, and this is going to be the buffer size. So I'm not going to label this here because there's no point, but just know that this is going to be a buffer, this is going to be a size. Example for this. This is going to be void data. Size. Doesn't look like this is getting changed anywhere, so we can alias it. This is process ID. And this is the actual data. Okay, so this is packet header. Cool, so what's going on here? This is passing it in as a log packet header. Payload size. If the payload size plus this is like the size of a log header is not equal to the data size, return 0. So I'm not sure where this gets set immediately, but I think this was set in the constructor. So this should actually be fine. This is, I guess, get payload size. Son says that's exactly what it's called in the SDK. Great. Glad that my guess is accurate. Set process ID. Okay. So if logger implementation destination at 1. So this is going to be log to target manager, which we know. It's getting that global object again, which is interesting. It's incrementing the reference counts. Unknown global object 0. Yeah, this is increments reference counts. Object 0 and ref. Any Pete says mic levels are a bit low. I'm sorry about that. I've already turned them up once. I can turn them up a little more. 1 second. But I think I'm just not that loud. Okay, that might be an improvement. A little bit, maybe. I turned it up again a little. If logger implementation destination at 2 is 0, if not UART. Okay, why would this be here? What does it actually do? Try wait any on some event. Okay, what is this doing? This is acquiring some value, probably. Let's probably acquire some lock. This is checking that it's locked. This is retrieving something from the current thread, which I don't care to look up. I think this is just more mutex code. This is checking if a global is 1, and if it is, it's waiting on events. And then this is unlocking that mutex. Great, okay, what is this global? Where is it getting modified? this is getting modified in the flush thread. Okay, I'm going to make a wild guess here. I'm going to say that this is probably a G flush initialized, and this event is probably G flush. It's probably an available event. It's probably is, can I do a flush? This is probably, am I allowed to flush? That would make sense. Okay, I don't see code for UART when sleeping here, but I know that's been there in previous versions. Okay, I'm going to make a guess, which is probably in source. This is probably something like if, I don't see any UART code here, actually. So probably this version of LogManager doesn't have support for logging over UART, but they didn't if-def stuff out entirely, I suppose. This probably looks like if G log destination at UART stuff that got if def out, else if maybe we can flush, and G log destination at other stuff. Probably UART of sleeping, but we can't actually verify that. There's no way to know that. Stuff that got if def out. That would make sense, because if it can't log to UART, then this maybe if we can flush thing will be called because it has side effects, presumably, even though whatever was inside of this branch probably got if-def'd out. So that is my guess there, from experience diffing code that has a lot of stuff if-def'd out of it. But we can't be sure, but that makes sense to me, and so I'm gonna roll with it. This is some other global. Where does this get stored? There's a store to make it 0. There's a store to make it 1. What's this? Okay, I know what this is. This is the service implementation stuff for some object. There are 3 commands that would make this this. So this is a LogManager getter, a log getter. So this is log getter. And what is that function actually called? Start logging, stop logging, get log. Start logging, log getter, stop logging, log getter, get log. What does start logging do? Start logging, G. That makes sense. It sets the global to 1. Stop logging sets it to 0. That also absolutely makes sense. Get log is probably complicated, and we'll reverse it later. Yep, that's a mutex lock. That's stuff. That's also stuff. We can deal with this later. We will come back to this. But I have convinced myself that that is the log getter stuff. Okay, so if log getter is logging, and this is going to be like log to log getter service. I'm guessing that this is going to be like a flush function for it, given we know that they're passing flush functions around elsewhere. That would make sense on its own. But let's dive in. So let's say that this is flushing available. Continue again. That is flushing available. Ugh. I really hate when I can't alias variables right. I know that it's because they're different types, and I would just need to like set them both to bool or something, but that's fine. What is it doing here? We succeed. Okay, this is actually probably not a reference count. I bet this is not a reference count. If this function, which is probably a log. Oh, Hedgeberg's here. Hey, Hedgeberg. Presses are fucking stopped. Yeah, it's actually probably not packet counts. So if this succeeds, I'm assuming this returns a bool. We go here, which continues on to maybe log it to UART. If it fails, we enter here. And if this fails, we enter here. So this is the failure path. So this is definitely going to be increment drop packet count. I accidentally removed unknown global object. Unknown global object 0. Hedberg asks, Sire, did you turn off the fans? And kind of. I set one of the fans to be on medium instead of high, and I set the other one to an intensity of 7 instead of 10, and that seems to have significantly lessened the white noise, and I'm still not dying of heat stroke, so I think that it's probably a good trade-off. I am reasonably happy with the trade-off there. That shows not white noise, brown noise. Ah, yes. That's something that clearly I would have known. Drop packet count. Yeah, that's fine. You are almost certainly technically correct. I just call it white noise because it's the thing that I put on when I want to sleep. I actually love loud fan noises when I'm trying to sleep. Okay, so what do these two functions do? This one calls all this code. This one does jump out. Okay, something's wrong here. What is going wrong here? This is jumping to this, and this is being interpreted as a function chunk for whatever reason. Okay, let's make that its own function. Let's make that its own function, and let's look at these again. This is calling stuff with the inputs, the 2 arguments, and 0. Okay? And what is this doing? This is calling it with the input, the 2 arguments, and 1. Okay. I'm going to assume that this is, in fact, is flushing available. That would make sense. This is getting some object. Okay, this is getting another global object. Great. Get unknown global object 1. And passing it a packet header and a data size. And then this is going to be like, can we do a flush? Or should we do a flush? Yeah, this looks like a real big global object, so let's get started. Okay, it's at 0xEO is the lowest address that I see. The highest address that I see is 48. I can't do hex math in my head. Minus 0x3EO. Okay, 0x68 bytes. That makes sense. I don't know why I said that makes sense. It's not like it would make any less sense if it was a different size. Struct unknown global object 1. Third. 0. Okay. So what's this actually doing? Stuckpistol says, not having Windows Calculator in programmer mode at all times. I'm disappointed. Let me disappoint you further. I have never used Windows Calculator. I've never used it in normal mode. I have never used it in programmer mode. I've never used it in scientific mode. I don't know how to use Windows Calculator. I don't know that I've ever used it for anything. But okay, it looks like 0EO F8. It's getting pointers to things in itself. That's weird. But okay, it looks like this is probably some kind of sub-object of size 0x18 bytes. It's also assigning pointers to the first thing here later. So that's probably going to be, let's call that noun object 1 sub object 0. These names are terrible, but I can always change them later, and I have no idea what this is. This is keyword 0, keyword 0x08. Hedgeberg says, structure view is the only good part of IA. No, structure view is fucking awful. I hate structure view. Structure view is like one of my least favorite things of all time. Okay, if I want structure offsets, I can highlight over the structure member in the decompiler. I don't know why I would ever want the thing that you're suggesting. Unknown global object 1 sub Also, this is in fact how I name variables, so feel free to judge me for that. Let's make those lowercase b since I think I didn't fuck that up. And then it looks like there's pointers, so let's do this. Subobj pointers. Actually, there's 2 of them, so let's just make that subobjects 2. That would make sense. Actually, no. It makes more sense to not have this be an array because maybe they're independent and it'll be a pain later. Pointer 1. Okay, what did I fuck up? This probably is a capital B then if I did that wrong, which would be really annoying, but I can fix that in a bit. Nope. Okay, what am I fucking up here? Is it just going to complain about this? Yes. Okay, so what am I doing wrong? Object 1 sub, obj, okay. That's dumb. Doing really professional things here if you can't tell. Now, I would love to have a way to not run into dumb shit like this when I'm working on these things, but I have yet to find any way of not running into dumb shit when I'm working on these things. Known global object 1. Okay. Oh, structures, duh, local types. I fucked that up. Should be a pointer. Should be a pointer. Okay, this is coming right after. That looks like it's some kind of a size. That looks like it's some kind of a function. Some size. This is probably keyword. Some function. Probably 3 arguments. It's probably less actually, but I like 3 arguments as a base heuristic. What's going on here? Did I put in the right thing? I did. Let's recompile. Oh, it's probably aliasing these as their own things. Yeah, that's probably better. And it looks like it's mutex, a mutex, something else, a byte, and a keyword. So let's just add all of those really quickly. Keyword mutex 0, keyword mutex 1, keyword unknown 0, keyword unknown 1. Chris says, Mike, HexKWizzy did publish an iPatch decoder for T214. As the person who wrote half of the code in that iPatch decoder, I have in fact seen it. Yes, I have seen that a Mariko iPatch decoder has been published. I was heavily involved in the publishing of that decoder. A 0 over the rest of the things, a byte and a keyword. Okay. Bytes, some bytes, and keyword, some keyword, and struct. Son says, I just spam out the size in keywords and the field starts to be larger or smaller. I can change that. I do that too. When I'm reversing not on stream, I'm actually putting an effort to use names here. I'll do keyword 00, keyword 08, keyword 10, keyword 18. For the whole size of the struct, figuring out I can fix it later if it's wrong. But I'm making some effort to not do things the dumb way, since this is objectively better. G unknown object 1. Cool. So this looks all good. Okay, it looks like the first member is a pointer to something. Some size is 20,000. This is a difference of 20,000. Okay. I am going to predict that these two are pointers to buffers. I'm going to say that this is a buffer. And then, let's see, this subobject is, let's rename subobject 0. Buffer info. This is probably metadata about some buffer. That makes sense. Char s object 1 buffer 0 20,000 s sub 0 0 s it's actually obj 1, so we should call it that. Sub I to 0, subtract to 0. This is some initializer. It's probably, if this is a mutex, this is probably like a condition variable or a light event or a signal or some other thing used for synchronization. It's probably an SDK object. Let's look around there. Stuff usually ends up in order. 0. It's near condition variable code. It's probably a condition variable. I'm not going to label it as such yet because I'm not sure, but this is probably a condition variable. Yeah, okay, this is event stuff. This is a condition variable then. Because this kind of internal event is a mutex and a condition variable. So that makes sense. Yeah, that was a good call. Thank you, Masan. This is going to be buffer size. It looks like it has 2 buffers, which are separate. It has some kind of flush function, probably. Let's call this unknown object 1 flush function, maybe. So that if I need to find it later, I can type flush in command or control F and just locate it. So we can pointer 1, topic 0, 18. Yeah, this should all be good. I don't know why it's doing that when subobject 0, 18. Oh wait, yeah, no, that is absolutely right. Okay, great. So this is going to be object 1 log packet. Or well, just log probably. Actually, object 1 log without flush. Log with flush. Since this one passes 1 and that one passes 0, depending on whether or not flushing is available. It's going to probably be object 1 log impl. It's going to be packet, it's going to be data size. That'll be all good. Okay. And then global object 1. It's going to be this. This is can flush. This is data. This is a data size. Hedge says, just order burgers, fucking starving. I hope that is a description of you and not like a command. I don't really need to eat right now, and I'm also not fucking starving, so I don't think I will order burgers, but if that's about you, all power to you. Okay. If data size, okay, so yeah, that makes absolute sense. I don't know, SDK condition variable type weight on the unknown. Yeah, okay, these are definitely condition variables. Convar 0, convar 1. Okay, awesome. That is better description of the initialization than I was even hoping for, to be honest. Okay, so it locks this mutex. Given that this is in the logging stuff, let's call this the logging mutex, which would make sense. Let's call this the logging buffer info. Logging buffer info. 0x08. 0x08 will end up being set to this variable plus data size. Okay, so that's probably how much we have logged so far. Call this data. Let's call this can flush. Let's call this this. Okay. So I'm going to say that this is probably size. This looks like a reference count. It's incrementing it here, and if it decrements it with the mutex locked, then it will signal, yeah, SVC 1D. I think that is signal process wide key atomic. Switch brew SVC. Let's find out. X1D, I'm pretty sure that's signal process wide key atomic. Yeah. Maybe keyword, D-word. Great. Yeah, that absolutely makes sense. Hedgeberg says you can read that white on white text. I can read that white on white text. I can read that white on white text well because I have eyes that are capable of seeing things. What's bad about the text? It's totally fine. Are you typing the text in IDA or the text in Firefox? I'm not sure which part of my text is being criticized here. Hedgeberg says, I have perfect vision, so eat my shorts, asshole. Okay. How do I change the colors of the text? I'm happy to make it more readable. How do I actually do that? I have no idea how to do that. Palette 1, palette 2, that's awful. Those are all terrible. Why would I ever want that? I cannot imagine why I would possibly want any of that bullshit. Well, if someone can get me a theme and tell me how to install it that makes this more readable, I will install it. I am not attached in particular to any of this. Hedgeberg linked me to IDA Nightfall, which is a dark color theme for IDA. Okay, how do I install this? wget on that file. Okay, I can just save that in my host and then copy it over. I want you to know I'm downloading this right now. I will do the thing you're asking for. Sorry that you can't see me doing this because I'm doing it in the host system and I'm going to copy it over. But I am doing it. Options, colors, where is import? Okay. Import. Okay. That looks terrible. That looks absolutely awful. But that's fine. I will continue with this. Do I need to restart IDA? I can. Store this. I mean, that was just not pleasant to look at. I was in logger implementation. Log. I'm going to say these colors look like shit. I mean, I will use them if it's what you guys want, but it really looks like shit. I'll deal. I'll use what you guys want, but Jesus Christ, those colors make me want to like claw my eyes out. Okay, options, colors. How do I revert that? Can I just go back to this, maybe? Okay, that's how it was. Sarkpixel says this one is better. Okay, I'd prefer if this stream didn't turn into like hours of playing around with the IDA equivalent of fonts, but let's give this a try. IDA constants.clr. I mean, I'm happy to play around with fonts with you guys, but that's not the point of this stream. Colors. Let's import it over this one so I don't lose the white on white that I actually like. Okay. That's... Do people prefer this to how it was before? Is this more readable? I can live with this. It's still weird, but I can live with it. All right, quick vote. This or go back to the way it was before. Not sure how I like this like Halloween retro Game Boy stuff in the header here, but that's fine. I can live with it. Yeah, I'm gonna revert. I think this looks worse. I think this was a downgrade. Okay. So, if the buffer size minus the current size is greater than or equal to the data size, that would make sense if we are doing some kind of check to see if we're overflowing the buffer. Okay, I think that this is going to be checking buffer size minus current size. Okay. I think that this will break if there is enough space. Any chance that is an unsigned compare? It is sub and BCS, so no, I think it's signed. That is a signed comparison, I believe. Okay, it looks like this increments this variable, and then it waits on this condition variable. Then it gets the Boolean that we were unsure about. Interesting. Oh, does it tell you? Oh, it is an unsigned operation. Okay, that is unsigned. Never mind. But I also think the current size, that's a keyword actually. That's a keyword. I don't know, maybe there's something here. I'm not particularly interested in seeing if there's like some overflow in this because this is a development unit only system module anyway. And so no code that we find here is usable on retail. So it doesn't really matter if there's bugs. This is probably some kind of a count, question mark, some count. Let's call it logging current logging count, maybe. Hassan says number of threads pending write. I totally believe that. That super believable. Okay. We're not sure what this Boolean is, but we'll figure it out when we look at the actual logging code. Doesn't really matter. There's an unlocked mutex here, and this jumps here via goto. What I'm going to conclude here is that this is a failure path, and this is a scoped lock that has been acquired for trying to log to this condition variable. Yeah. I'm going to say that I think that this is just a scoped lock being done right here, since it's also unlocked over here. So there's probably an implicit scope here. So what is this doing? This is saying that this is probably a destination. Destination is the buffer plus the current size. Yep, that makes sense. Current size is current size plus data size. If we're here, then we know that it has enough space to copy it in. My son links me to something on Imgur, which I absolutely believe. Yep, I believe everything that you just linked me to. He says no guarantee on how correct your notes are. Your notes are probably right, but I'm going to mostly ignore them because this stream is about going through the process of reversing stuff anyway. And so it is, there's no point in just taking all of the labels you have when I can demonstrate the process for labeling stuff. But yeah, now I agree that this is also probably some kind of current logging count. I think that this is are we logging? If we are done logging, then we signal it. Okay, so something is presumably waiting on this condition variable. And there's probably some code somewhere else that actually does flushing. That's fine. That all makes sense. What is this function that we saw here in this global object? Because that is a really interesting question to me. This is probably the flush function. So let's assume that this is a data, and let's assume that this is a data size. What do we think this function is going to actually do? Do we think this is a flush function? It's probably a flush function. Okay. Okay, so there's a global and consistent one here. This is probably some local static variable. So let's call this static, some boolean. What is this doing? This is looking like it's doing timing stuff. Okay, well that is completely unambiguous. Get standard user system clock current time. Okay, that's super unambiguous. Current time, get system.tick doesn't actually take an argument, so that should be fine. If we fail to get the time from the system clock, it looks like they do system.tick, and they do a whole bunch of horrible arithmetic. This is the number of ticks per second. This is probably just a lot of logic to get the system clock time depending on the current system tick. It looks like there's a one-time initialization here that's happening. So let's see what's going on here. This is probably... Is that a real argument? Interesting. Does A3 ever get used? It does. Okay. Four. Yeah, I don't want to alias that to anything. It looks like this is doing log packet header size stuff again. Let's see. If the time is failure, it calls all of this. Do we care about what this does? Do we just assume that this is some kind of adjustment to adjust it to current local time? Probably. Oh no, wait, you're right, StuckPixel. This is absolutely a result. This is the actual time. This is get time result. Get system.tick doesn't take in any arguments. Let's fix that. That's better. Yeah, no, I agree with you. Some kind of adjusted time. This is taking in a function and a pointer to the adjusted time, which is totally fine. Call this adjusted time. This is probably just converting the time from like nanoseconds to like minutes or hours or seconds or milliseconds or something along those lines. But I can't read this kind of shifting so well, so we'll just assume that it's doing something. Let's see. Taking in a log packet header, I think, maybe? No, that doesn't make sense. This is some other type. Just taking in the actual data as the input. So what is going on here? Interesting. I'm going to come back to this because it isn't immediately obvious, and this function, if it's like parsing data, will probably be called later in a context where we might understand what's going on a little better. And that sounds a lot better to me than trying to reverse it without any further context. Okay, so this is some kind of time initialization. This is another static initializer, I suppose. It must be. This is initializing some other global variable, which has a condition variable, an event, text. This is a really big object, and it isn't doing a whole lot, so I'm not going to create a struct for it yet until we know what's going on here. And then this is another constructor, which is just return 0. This probably does something else if it's not if def out. And then this will call data and data size on this. So this is probably actual log implementation, and this is probably, is it logging it to 2 different sources? It must be. Boy, another one of these. Okay. Initialize mutex. This. Would people rather see me dive into this log function or this log function first? I'm happy to do them in either order, and so we can go ahead and do them in either order. And it looks like this is like, did we succeed overall? Success. And if we succeeded, it sets this to 0 so that it'll get the time again the next time. S has system time. Because, dude, you gotta remember, even in reswitch, the majority of people don't know reversing super well. Yeah, no, I am not assuming that people know reversing super well. I don't think I was asking a question that needed knowledge of reversing. I was asking if people would rather see me dive into this one or dive into this one. I think what I'm going to assume these do is this is an inlined constructor for this global object. This calls log on this global object. This gets a second kind of global object, and this calls log on the second global object. And the success is the OR of the 2 calls. They're going to default to your judgment since they trust you to know the system better. Yeah, this is a low-stakes question because it actually does not matter at all which order you do them in. I don't have an opinion here, which is why I was asking. I'm happy to flip a metaphorical coin, but yeah, okay, why not first? I guess let's create some kind of a struct for this, if nothing else. Create a struct type. Struct global object 2. Looks like there's a gap of 11C0, and there's a convar, and then there is an event. I don't want to deal with these struct for events. Yeah, that is a really big gap, which is unfortunate. Looks like this is actually d-word event of 0. D-word, fine, I'll make a real struct. Struct event type. I know this struct somewhere, but I don't remember it offhand. Keyword mutex. Keyword. Timeout, maybe. Keyword. Team. Convar and event. Oh. What did I do wrong here? No, so this is a global object. Forgot type def. I don't think type defs are relevant because... Oh, right, I just need to do it twice that the types propagate. Where is unknown global object type? Let me do these by name. No, I didn't want this to be an event type. I wanted this to be a type insert. I forget what I just named that. I completely forget what I just named that. If I do my ordinal, it should be like 46. Okay, well, guess I just lost that. That's fine. Create new struct type. It was 11C0, then a convar. Struct unknown global object 2, which was bytes of 11C0, then a convar. And an event type event. That's better. Now global object 2. Event. What is going on here? Is this just smaller than I thought it was? How big is event type? Event type is 18. No, okay, so I just completely mislabeled this. That's fine. Keyword. Let's just delete the event type because we don't really need it anymore because it was clearly just wrong. Create new struct type. Event type. That's better. There's like real stuff that I could be importing for this, but I just don't care. Probably size 1200. That would make sense. Yeah. Something, it looks like there's one more keyword in it that I missed. I wonder what this object is. And Hedge says, yes, I figured that most of you guys here are not reversing experts. Do any of you guys have any questions that can be answered? Event might be positioned wrong. I also believe that. Event +4. Yeah, it is positioned wrong. Thank you for noticing that. Okay, that's better. That is definitely better. And it looks like there's a 2 mutexes at 11E8. Mutex 0, mutex 1. Cool. And actually, I'm not going to call this unknown global object 2. This is probably a target manager logger. Actually, I will wait on renaming it to that until I actually verify that that's what it does. I shouldn't get ahead of myself. Because also I'm not sure. Last one should be 11F8. Yeah. 11F8. 11F8. Yeah, that'll do. Great. Okay. That is probably about as much as I need to pay attention to this. I do wonder what all of these unknown objects are. That would be nice to know. But we'll find out later. We'll find out later, probably. Okay, so let's call this unknown global object 2 log. Also, are there any other references to this? No, this is the only reference to this. What is this? Okay. Pretty sure the first one just counts dropped packets. You mean this? What do you mean by the first one, Masan? Yeah, I would absolutely believe that. That would make some amount of sense to me. Anyway, let's see what this does. Global object 2. Load exclusive, allow.info +1. Okay, so let's conclude there that that's not actually a keyword. That is probably 2 D words, since that's the one that got set to FFF. This is probably like an atomic integer. Atomic int 1 plus 4604 plus 11FC. Okay. Is this not dereferencing this? Hedrick says, question, in this context, what makes an int atomic? It's using ARM v8 atomic instructions. This is doing an load atomic register, and then it'll do like a store exclusive later if it's modifying it, probably. Okay, virtual socket collection shut down. That tells us a lot about what this is doing. This is going to be an Htcs shutdown. Yeah, it's just an int handled with atomic only instructions. It's not quite thread safe, but you are guaranteed that it will never have like race conditions. I mean, you can still fuck things over using atomic integers and multiple threads, but any read and write to it is not going to be interrupted by another thread. Okay, so this is probably logging stuff over host target connection sockets. That would make sense. This is, yeah, fetch socket send. Okay, so this is actually not doing anything especially special. This is data size. 4 is data size. P5 is 0. If not data size, I have no idea what this check is. Why would it be checking for 32-bit alignment on an undereferenced variable? That's bizarre. Like, this isn't doing a dereference, so I don't know what. It also only happens if data size is 0, so that's especially bizarre. This might just be some bit of compiler wackiness, but okay, that's fine. It doesn't really matter. Data plus his data size minus size. Oh, I see what's happening. I absolutely see what's happening. Not compiler wackiness, that's me being bad at IDA. So I probably aliased something to be A1 that's not actually A1. Did I? No, okay. V7. This is probably just decompiling really poorly. What is actually going on here? Load exclusive arrow. Okay, it's doing 2 load exclusives. Masan says, does that actually reset aliases? Yes, it does. That is what I do to reset aliases. I wasn't aware that there was another way to reset aliases besides undefining the function and starting over completely. But undefining the function and starting over completely does work. This is probably just sending it over HTCS. Yeah, this is definitely just going to be like HTCS send. Oh, you know what I bet this is? I bet that this is an offset. That would make sense. Data size, let's call this data again. That makes absolute sense. This is some kind of result code, which it's reassigning to a 1 for no reason. This is a comparison to see if it's less than 0. That's super weird, but okay. If it's less than 0, then we break. Otherwise, this is the number of bytes returned. I'm not going to name it because it's aliasing it weirdly. But number of bytes returned less than 0, we break. If the number of bytes, if the offset gets incremented by the number of bytes that we actually sent, if the offset is bigger than the data size, then we return that the offset is equal to the data size. So this will return true if they actually log exactly the number of bytes that we wanted to. And it looks like if it shuts down, which will only happen on a failure here, which is to say that it wrote, I did write HTS, thank you for catching that. If we fail and it returns a negative value, I don't think that's a fail on Nintendo's part. I guarantee you this is just IDA's decompiler doing stuff wrong. If it returns less than 0, then it will shut down the host target connection, and then it will sleep for a second. and there's probably a thread that's receiving this that we saw earlier in initialization that will like restart it or something. Which weird check? This one? Let's see. Move W8 LNFC, add X0 LNFC, load AR. Oh, okay, I see. It's because it's loading two things from this variable, and IDA and load atomic are just, they don't play well before IDA 7.2, and this is IDA 7.0. So that is in fact just IDA being really bad at atomic instructions. Okay, but that makes sense. This is logging over target manager. So let's call this target manager logger. Target manager logger. And this is target manager logger ::log. Leo says you sound exactly like somebody I've heard before, and I can't figure out who. I'm very sorry for your loss. I'm very, very sorry for your loss. Yeah, G target manager logger. Yeah, target manager logger log. Okay, so that's what that's going to be. That all makes sense to me. And so let's see what this second logger is / does. It's another global object. It looks like it starts at D18. Okay, that's a huge gap, but that's fine. It goes to A8. What kind of a store is this? That's a store pair keyword at D8. Okay, so that's probably a keyword. So let's make a type for this. Struct unknown logger. First thing on there was definitely a D word, I think. D word mutex. Let's see what the other ones are. There is a word. Probably a word. Okay. Let's see. Logger. Word. Some word. Before. And this is 2 bytes above that. So let's say that that is a single byte. So x1e. If you add 0x, this is like an 82 byte gap. So let's just make that a character array of 82 and figure that we can correct it later if there's like padding, because that makes our life simple. 06, x82. And then there's 2 keywords, it looks like. This object, let's make it a unknown logger. So that'll work out. Yep, awesome. That looks how we expected. Does this do anything? No, that's that return 0 function that we saw earlier. So this is get unknown logger, which makes sense. This is g unknown logger. This is either a Boolean or a string. It's probably a Boolean, but it might be a string, since they reserved a bunch of space and it's not writing anything else there, and it's just writing a 0 to the start of a bunch of space. That's stringy, but it's next to a word. It's probably a Boolean. Unknown logger log. Okay. Okay, well, I guess we can know immediately what this is. This is going to be logging to the SD card. That's really easy. Good to know. Yeah, I also love debug strings. Debug strings are awesome. That's not actually a debug string, that's actually it retrieving a setting from system settings. But I love debug strings. I love when there is human readable shit telling me what things are and what things are doing. That is the best. It's super, super nice. So what is this doing? This is some kind of static variable. S initialized sd send static. Okay. If we have initialized, then it's going to check this Boolean. I'm gonna guess that this Boolean is maybe the SD card enabled? SD card enabled, maybe. That would make sense. It's not really enabled because it's using the value of enable SD card logging. Oh wait, I guess actually it is literally enable SD card logging. V14 and V16 is not equal to 0. Yeah, so this is got the setting. And got the setting. The setting was 1 byte, and that 1 byte is not 0. Please fix get settings item value signature. Yeah, you're probably right. I should fix that. Void out. It's a keyword outsize. Word outsize. Const-care key, it's a const-care name, and it's, I think that might actually be it. Yeah, that's probably it. Yep, that works. That is definitely a lot more readable. Okay. So this checks whether or not we can do SD card logging at all, and if we can't, it returns early. So from here on out, we should assume that we can do SD card logging. So what is this doing? It's calling some function. This is calling some function that returns a bool. And if this function returns true, then it retrieves something from us. It opens a file. It writes, what is it writing? Yeah, it is writing the buffer that we passed in to the SD card, and then it's closing the file. So I'm going to guess that this is like setting up for actually writing. So if SD card logger set up for write. And if that succeeds, then it'll do a bunch of stuff. So let's see, what does setup for write do? If this low byte of 4 was a word, so I guess we can infer that it's actually a couple of booleans. Probably. Local types. Can I guess that this is 2 booleans? Yeah. Bool of 4 is accessed here too. This looks like some kind of like usable or enabled. Let's call it logger usable. Return 1. Yeah, okay, this is definitely going to be set up. This will be like set to 1 once this has been called. So this is just them deferring initialization. Has set up for right. That absolutely makes sense. Actually, this is probably initialized. That makes more sense. And this is probably just initialize. Not sure why it's assigning x29 and x30 stuff. It's just failing to see that there's a stack frame here. That's really dumb. Okay, what does this do? v10 and v9, which are both on the stack. Awesome. This looks exactly like the kind of function that I hate. Great. Looks like it's returning a void. At 1, okay, it's returning 2 booleans. Bool out, bool 0. Out, bool 1. Out, bool 0. Apple 1, apple 0. Okay, so this is some kind of get a mutex. This probably initializes something. Do I care about what this is? Okay. Open SD card detection event notifier. Okay, great. This is open SD card detection event notifier. And then this is probably actually getting the detection event from this notifier that it just created. And I don't really care about how that works, because unless it's called elsewhere, it just doesn't matter. And it's assigning to this global this function. So what is this doing? Is SD card inserted? Great. Is SD card inserted? This is going to be G is SD card inserted. Yeah, the FS debug strings are really consistently excellent. Yeah, this is trying to wait on the event. So this is probably doing some stuff. Try wait event. This is at +8 from this. So this is definitely the actual detection event. GSD detection events. Does it actually use the second argument? No, it doesn't. It only takes one argument. Because try wait event just takes a pointer to the event that it's trying to wait on. Okay, this is already looking a lot less awful, although the atomic stuff continues to be horrific. If we succeed, then it's going to say this is SD card inserted, and this is 0. This is actually a failure case, so let's see. It looks like V8. Okay, so this is out is inserted, and this looks like it's out succeeded. So this is going to be like, did we succeed in finding out whether the SD card is inserted? And this looks like it's going to be, did we, is the SD card actually inserted? That sounds right. They might be in the wrong order, but that's fine. Get SD card inserted info. This looks like it's bool. This looks like it's bool. What order did I have those in? Succeeded and inserted. Get SD card succeeded. SD card inserted. If we failed, then it sets this to 0. Okay. If we don't have the SD card inserted, 0. This is looking like a boolean. Okay. If this is not 0, then it returns 0. This is like checking if we've already set up. These are all failure cases because it should get into this state without something weird happening. I'm going to guess that this is a mount. Yep, this is a mount. Mount SD cards. This is going to mount the SD card to the mount point SD card : / Boolean 5 is 1. Okay, there is no way this is anything other than is SD card mounted if it's being set to true right after mount SD card succeeds. LM SD card log output directory. Oh, I definitely know what this is. NN settings. W debug get settings item value size. Output directory. Output directory size, and then it'll actually get care out directory 80 output directory. And it verifies that the size that it gets from the actual setting is what it expected from the size getter. Okay, this is definitely snprintf. Ugh. Yep, it's snprintf. snprintf. 13. Careful. This is like a directory path, because that's really a directory name above there, and this is a directory path. By the way, does anyone have any question who's watching about all the stuff that we've done so far, or about the reversing that I'm doing? I've gotten next to no questions, and while I'm happy to just read aloud my reversing efforts in the hopes that it's interesting, I'm not sure whether to interpret like no questions as this is uninteresting, or no questions as in I don't have any questions. So what is it doing here? 402, that's already exists. I bet this is create directory. This is create directory. Great. Create directory. Viking says, this is a lot more interesting than the previous stream. That is good. It is my hope that this kind of reversing is interesting. And I mean, once we have fully reversed this, because this can be like a series of streams, I'm going to end up re-implementing this, which will hopefully be fun. Yeah, I'm kind of being forced to take my time here because I don't actually know what I'm doing here, and I definitely know what I'm doing when diffing trust zone. It is definitely something that I know. Oh yeah, if Hedberg makes a good point, and that people probably don't know what to ask because this is new, and people who do have questions are new to this and think their questions are dumb, and so they might be afraid to ask. Let me be very clear. There is no such thing as a question that is too stupid. If you have a question, feel free to ask. Nothing is too stupid. Yeah, this is some kind of a Boolean, and this is, it looks like @1 is actually the path here. So let's edit that. And let's call that bool, some other bool. 129. That makes sense because it's 0x80 and they reserve space for a null terminator. This is going to be a directory path probably. Actually, I guess this isn't quite a directory path. This is probably like a log file path, and this is probably making the log file path. SD card logger make log file path. Bapsack 1994 says v7 equals create directory, casting directory path to an N64. Yes, that is a constant character, but I didn't care to reverse this in great detail, and IDA guesses the types. An N64 and a constant character pointer are marshaled around. They're passed by one function to another the same way. They're both just in a register, and so IDA guesses that it's an N64 until you tell it that it's actually a string. You are absolutely right. That's just a relic of IDA not really being sure how to deal with stuff. And you can see that I can just change the type to be whatever. So this all looks straightforward, although this actually looks like it's writing stuff. Cool. This is writing at offset 0. It's reusing the space on the stack for a file handle. That's really gross. Okay, so it says directory path here. Know that this is actually passing in a pointer to a file handle, and then it's going to be using that file handle here. So it's going to open our output path. It's going to write at offset 0 these 8 bytes, HP, which I guess is a header, and then v15 is 1, and then it's going to write 1, which is probably like a version number or something. Log file header. Kind of hate when IDA does that. Log file header. Low byte. Yeah, okay. It's writing 8 bytes, but it's actually... Is it really storing that as a single byte? That might end up writing shit from stack. Realistic asks, how much of the switch is left to reverse engineer? Good question. Really good question. Let me pull up the title list, and I will just go down the list right now and say what I have and haven't looked at, and what I do and don't feel confident about. The Switch's operating system is really big. Title list. What did I do wrong there? Oh, lowercase l. I fucking hate MediaWiki. MediaWiki is so bad. Yeah, okay. So, file system services. I spent a lot of effort reverse engineering file system services. I could re-implement file system services if I had like 6 months to a year. So this is totally reverse engineered. Loader, I have re-implemented it. NCM, ADubs has re-implemented it, and I have also reverse engineered it in great detail. I have reverse engineered I have re-implemented process manager. I have re-implemented service manager. I have re-implemented boot. USB system module, I have done a fair amount of reverse engineering for, but I don't really understand USB, and so someone who is not me will have to tackle this in greater detail to really understand it. But I understand it a little. I've looked at all of this stuff. I had to reverse it a lot when I was adding support for USB communications to LibNX. So this is reversed, but not at a state where it can be re-implemented. I have like half of a re-implementation of Target Manager Agent. I completely understand Target Manager Agent. It's a hilarious system module. It has like dozens of bugs. It's great. It's also dev only, but that's fine. Boot 2 is a for loop that launches like 20 things. It's re-implemented inside of Process Manager in Atmosphere. So this is totally done. Settings. I have reverse engineered settings well enough to re-implement it. Yeah. Bus. I have not reverse engineered bus very much. Hex KYZ has reverse engineered bus, and so he could probably tackle that if we needed to. But yeah. Hedge asks, are the IDC script label files uploaded on the wiki right now? I'm not sure if they are. I'm not sure what IDC script and label files you mean. Or I don't think the wiki stores any IDA scripts. If you mean like the reswitched wiki, I think the reswitched wiki is dead. We definitely used to host that kind of shit, but I'm pretty sure that wiki doesn't exist anymore. Switchbrew definitely doesn't host anything. Yeah, I know what an IDC is. I just don't know what you mean by the script/label files. Like, I don't know what you're specifically referring to. Bluetooth. Okay, so Bluetooth is used for PAMA communications. It also does other stuff that other people probably care about, but I only care about PAMA. And PAMA, P-A-L-M-A, is the code name for the Pokeball Plus. I have completely reverse engineered all of the functionality in here used to communicate with the Pokeball Plus, and not spent very much effort on the other parts of the system module. So I can definitely comment on anything in Bluetooth used to communicate with the Pokeball Plus, which, by the way, is just Bluetooth GATT, G-A-T-T. It's some standard. You could definitely make an Android app that talks to a Pokeball Plus over Bluetooth. It wouldn't be very hard. If anyone is interested in doing that, talk to me. I like have some notes that I can share about it. But yeah, Bluetooth is otherwise unreversed. BCAT, definitely heavily reversed. I know how BCAT works. I could re-implement BCAT. It's just that it uses SQLite, and it's really big and really complicated, and it's like way down on the to-do list because it doesn't get us a lot. But in like the fullness of time, if I do manage to just re-implement Horizon, which is the dream, this has the reversing work done. I understand BCAT. Debug Monitor is completely reverse engineered. I know everything about how I know everything about how Debug Monitor works. BCAT stands for Background Content Automated Transmission. It downloads content from the Switch's servers. It does news. It does like Wonder Cards in Pokemon are downloaded in the background. Like the events that you will get in Smash are background content downloads. It's anything that a game might want to download in the background. I have not looked at Friends at all. This is completely fresh territory. Someone can look at this and want to hate themselves, but Friends services looks awful. Just look at all of these commands. Not me. Someone else can do this. Also, I don't have Friends, so someone else who has Friends can look at the Friends system module. Oh, sorry. I guess I do have Friends. Hedgeberg is definitely a friend. Basanta's killing friends for memory is a good meme. That is a really good meme. That's such a good joke. Network Interface Manager, I have done some reverse engineering of, but not a ton. Like, if you gave me 2 or 3 days, I could reverse Network Interface Manager well enough to re-implement it, but it's been a long time since I looked at it. The last version that I looked at was like 5.x, like last year, so it's been a long time. Playtime Manager, I have not looked at all. This is completely unreversed. Someone else can look at Playtime Manager. Shell, I have completely reverse engineered Shell. I could re-implement it. Berkeley sockets, Tux looked at in great detail, but okay, so yeah, Shell. No one probably has looked at Shell other than me, because Shell is like really beta firmwares. It got replaced by CS and SCS, which is like Command Shell. This implements all of the functionality that used to be in Shell, but it is used to process commands received from a PC through Target Manager Agent. It is basically this command processor where you send commands over PC and it receives them and it does something on device for you. It's not quite Target Manager Agent because it's not receiving connections. It's a shell. It's not really a shell in the sense that like Unix would give you a shell, but it's a shell. Hedgeberg says, can you hit me up with the binary later? It would be fun to hack together a Unix shell over it. I'm happy to send you the binary for shell. Only old stuff has it, but I can send you shell. I can also just send you CS, which is like the modern replacement for shell, which got deprecated at some point. Anyway, Berkeley sockets. I have not done any looking into, really. Tux has done a lot. Talk to Tux. Hey, Kitlith. We are in the middle of reversing the SD card logger, but someone asked what hasn't been reversed in the Switch, and so I am just going through stuff to list everything that we've done. I've done a lot of human interface devices. Yellow's 8 has done a lot of human interface devices. There is definitely enough collective reversing that this is all known, but it's not like as well known as other stuff. Audio. Ognik has spent a lot of time looking at audio, so you would have to talk to him if you wanted to know about it. But he has definitely reversed the shit out of it. This is what we are currently reversing. We are currently doing LogManager. WLAN. Okay, so I have not reversed this like for real, but one of my units encountered this bug where bad data was written over PCIe to my device, to like the WLAN device, and so my console crashed every time I booted it up with a fatal error in WLAN, and so I spent like a week reversing WLAN well enough to understand why that crash was happening, and then I gave up and just left my console on a shelf for 6 months. And that like killed the power enough that it booted again, and I have not bothered to look at WLAN more since. Misan might have also looked at this back when we were thinking about Broadpone as it affects the Switch, but I don't know to what extent this is reversed. It's probably mostly unreversed. I have some notes, but nothing meaningful. CS is just newer shell. Backlight services is pretty well reversed, but I don't think anyone like could re-implement it. It's also just not very heavy. It's like a couple of commands. It's got like a backlight monitor and... Oh no, wait. I'm thinking this wrong. I'm thinking of LBL. LDN is local communications. Totally wrong system module. Local network communications. This is really well reversed because someone made a man in the middle for it. Like there is an existing man-in-the-middle system module for this stuff. And so I would say that this is extremely well reversed. Sorry, I thought this was LBL. Is LBL later? LBL is probably later. Yeah. NV services. NV services is mostly open source NVIDIA code that's like present in Tegra drivers, but it's also like indirection times a billion, and it's fucking awful to reverse engineer. It has lots of bugs. It's written by NVIDIA, which means that it's shitty. Like, written by NVIDIA and bad are the same thing in the English language. Yeah, this is... If you want to hack a switch, what you do is you hack the browser, and then you hack NV services, which is not hard to do. And then, wow, you have access to the GPU, which can write to physical memory. And wow, you have access to TSEC and NVDEC and a bunch of other shit that can like bypass the kernel carve-out up to a certain version. And like, I shit you not, hacking NV services on 8.01 and under is equivalent to hacking the kernel, because it has access to stuff that can literally just DMA the kernel. So this is NVIDIA provides you with free kernel hacks, the system module. Thanks. NV services is a huge meme. I don't think anyone would ever want to re-implement it, but it's also like largely open source. So, yeah. What a great system module. What a horrible system module. I feel super bad for Nintendo because Horizon has like no bugs, and then NV services can hack the kernel and is full of bugs and is written by NVIDIA, and Nintendo doesn't really have any options other than using NVIDIA's code because this is all interfacing with NVIDIA's hardware. So yeah, huge L for Nintendo, this module. If this module didn't exist, Horizon would just not really be hackable meaningfully because the kernel doesn't have any bugs. Power clock and voltage, Thog has done a bunch of reversing into. HexKYZ could re-implement this. HexKYZ knows power clock and voltage by heart and diffs it every update and sends me like a bunch of messages containing his diffs. And so I know that this is well reversed. I forget what PPC does. It's like performance profiles. Someone has probably reversed this, but because this is like system clocking shit, but I haven't reversed it. This is fuel gauge monitor too, which I actually have reversed fuel gauge monitor, but I haven't done any of the performance stuff. So let's label that as kind of reversed. I have literally never opened NVN Flinger in something ever. NVN Flinger stands for NVIDIA Nintendo, which is this graphics API they made together. It's like a compatibility layer for like Android to NVIDIA Nintendo. I have never looked at it. It might be full of bugs. It has NV in the name, which suggests to me that it's shitty, but I have no idea. I have never really looked at PCIe, so someone else is going to have to do that. I have never really looked at... That's not true. I've looked at Account. Account got deauth merged into it in 5.0, and I did a big reversing after it did that. Because this is what handles like the account login for games and shit. And I did the big post on Reddit about them implementing anti-piracy. I have a good account IDB circa like 5.0, but I haven't done anything since then. So if it has big changes since then, I wouldn't know about it. NS. So Nintendo Shell, N Shell, it's really big. It's also gotten like refactors for what it hosts like a million times. It keeps getting changed. It got a big refactor in 3.0. It got stuff moved out of it in recent firmwares. It used to host the stuff that is now shared databases. You know, I'm gonna be bold here. I could re-implement NS. I know NS well enough that I could re-implement it because I've reversed it on like 6 different firmware versions in really great detail. It's too big for me to tackle it in the short term, but I know Nintendo Shell really, really well. I could do it. So it is reversed. I consider it reversed. NFC. Yeah, this is reversed. NFC is definitely known. I've reversed both NFC and NFP, which is Nintendo Figurine Platform, which is used for Amiibo and lives inside of NFC. Sacrifice says, the question is, do you want to? I always want to. I want to re-implement everything, but I have limited time, and there are other things that beg my attention. In the fullness of time, I would like to do NS. Adab says, yeah, Adab quotes me saying that NV is shitty, and it's true. NV and shitty are synonymous. This is Power State Controller, which I reversed a lot. I know Power State Controller in great detail. However, I know Power State Controller, I know overlay notifications. System reports. System reports is the stuff added in like 6.0 that is like play reports, but for system state. This is the really big telemetry. This is where Nintendo sends the really big shit to themselves. This is how they track what you're doing when you're sleeping. This like tracks what you're playing. This tracks what you're launching in what order. This tracks all kinds of crazy things. I have done some moderate reversing on here, and I have not put my notes on the wiki because it's horrific telemetry and people get freaked out if I start to put my notes on the wiki. Like, I will comment, one of these commands literally has in the command name for anti-piracy. So, yeah. This is what fucks you if you're a bad person. Have fun. Capture services. I reversed this in moderate detail at some point. And it like handles the album contents. I reversed some of it. I reversed the like stuff that it uses for HMAC keys for validating JPEGs, but I haven't looked at it in forever, so it might be different now. I would not call this well reversed. AM. Oh boy, this is probably the hardest system module to re-implement in the entire system. AM is super complicated. It does a billion things. It is huge, and it is full of indirections. If anyone wants to contest me on that, feel free, but I will say I think AM is the hardest thing to re-implement in this entire system. Did someone say big attack surface? Yeah, AM has a big attack surface. It's just huge. And it is the only thing in the system that takes an IPC service object as input. Nothing else does. This is super complicated, super, super big. Yeah. I've reversed it a lot. Masan has reversed it a lot. Yellow's 8 has reversed it a lot. It's reversed. It's just so big that I wouldn't call it, like, understood fully. It's well understood, but not fully. SSL. I could re-implement SSL. I've done a lot of work with SSL. I could re-implement SSL entirely. That would not be hard. If that's like an interesting stream, maybe I'll do that at some point. But I don't think we really gain anything from implementing SSL, because I figured that if I try to re-implement SSL, I will make mistakes, and then those mistakes will cause people to get banned. And so I am very wary of touching SSL. NIM, Network Interface Manager. I reversed this a lot. I understand NIM. Well, that's not true. I understand NIM, and I understand NIM shop, but I don't understand NIM for e-content accesses. The other stuff, yeah, I totally understand all this shit. But, nope, not really understood. Keck, not present on retail, not present on debug. TSPM, not present on retail, not present on debug. These, who knows what these are? I mean, Keck was Street Pass on the 3DS, but I think Keck also means HDMI in like non-Nintendo lingo. So I just don't have a copy of this and can't comment on what it is. I have no idea what this does. I also have no idea what this does because we have never obtained a copy of it. I have re-implemented Secure Platform. Secure Platform is my baby. The Secure Monitor is my baby. Yeah, Keck is definitely HDMI. It's like HDMI consumer electronics control. It's a thing. Backlight. Backlight is well reversed. That's what I was saying earlier, is that we have reversed backlight. It's super simple. Bluetooth manager, I have somewhat reversed, but Not really. This is mostly unknowns. There's some stuff that's used here for, yeah, this GAT shit. This is used for the Pokeball Plus, and so I have an IDB that definitely goes into all of the Pokeball Plus stuff in really great detail. But anything that isn't used by the Pokeball Plus, I have zero ability to comment on. Error reports. I know how error reports work. I could re-implement error reports. That is probably an even better stream than SSL, because people might actually like a stubbed version of error reports that just like logs shit to the SD card instead of throwing it to Nintendo. People would probably like that. People would probably be happy if I did that. It's on the to-do list. Time. This actually lives inside of PCV, and this has never been included in any firmware that I know of, so it's just another one of these like Keck TSPM things that they reserved space for and then never actually became real. Display. I have done a lot of looking into display in trying to figure out how Fatal works when I was trying to add support for display to Fatal, but someone else would have to do this. It's so complicated, and display management, I hate display management code, so not me. Someone else do this. Parental control is well understood, but not well reversed. Nintendo push notification services. I've reversed a bunch, but it's like the same state as parental control, where I don't know it that well. Yeah, N penis, as Hedgeberg points out, because we are all 12 here. I'm not making fun of you. That's a really funny joke. I appreciated it. But yeah, Nintendo push notification services is this whole thing. There's like this article on it that Nintendo published about how they made it handle millions of users. Error upload. This too, I understand really well. And can implement. Hedrick says, nothing remotely funny about the human penis. Grow up. It's an important bone. You are entirely correct about that, except you're actually wrong about it not being funny. It's a really important bone, and its importance is what makes it funny. I could re-implement error uploading. There's nothing in error uploading that I don't know how to do. I have looked at glue/ARP 0 times. I don't even know what this does. I mean, glue, it's probably like miscellaneous shit that didn't fit anywhere else. But this does something, and I don't know what that something is. Error collection. I know what this does. I could re-implement it. We currently stub it in Atmosphere because it does literally nothing important except generate a bunch of reports. Yeah. Maybe I'll re-implement this for real some days, but the stub is good enough for my purposes, so I don't really care. E-ticket services. The system module that you can never reverse if you don't want people to think that you are a dirty wares kid. ES was documented by someone else. I have fully reversed ES. I'm not going to put any of my notes on ES on the wiki. They added a bunch of shit in 6.0. I know what all of this does. I'm not going to put it on the wiki because it has zero legitimate use other than piracy. Yeah. This is a bunch of stuff for managing tickets. This is a bunch of shit for managing e-licensing, which is the new like online content ownership verification shit added in 6.0.0. So that like Switch Online works. Someone else will document it. I'm not going to document it. I know how it works. It's fine. I have re-implemented Fatal. Gameplay recording. I have looked at a bunch. It has like NN::nerd symbols in it. So this is like written by Nintendo Europe, I think. But this handles gameplay recording. It's like when you hold down the snapshot button for 30 seconds, or sorry, you hold it down for a little bit, and then it saves a 30-second video. This is constantly saving the state of the display to memory so that it can record videos as needed. It's not super well reversed, though. It's just so much code. And it's all like display management code, so it's not well understood. C-Report. I love C-Report. I have fully reversed C-Report many times. I have re-implemented C-Report. It's reversed. I have re-implemented RO. Profiler is really simple. It only hosts this one command. It only hosts this one service called Banana. It has like 2 or 3 commands. It's super simple. I've reversed it a couple of times. It's understood. It's also dev unit only. Shared databases is all services that used to exist in NS that we all reversed when we were trying to exploit NS. Yeah, it's definitely understood. It's like Mies. It's like other shit. Migration. This handles moving from one console to another. I would say that I fully understand migration, but I would need like another couple weeks of reversing to re-implement it. It would be a lot of work, because migration does a lot of things. JIT. I completely understand JIT. JIT is very simple. JIT is not as good of a system module as people think it is, but it caused the like code SVCs to be added in 4.0, so I'm very happy that Nintendo added it, because we can use those for JIT without having to use its shitty API. JIT is like ridiculous. It has this interface where you have to specify code. You have to provide it an NRO that has a symbol that generates code. So you can't actually do JIT. You have to like have this like ahead of time JIT thing that will generate stuff, and it has to have a predefined function signature that has to have a symbol that RTLD can find. It's terrible. JPEG deck. This used to be elsewhere, but Nintendo decided, I think, that JPEG decoding might have bugs, so let's shove it in its own system module that has like no permissions, so that if someone manages to find a bug in our JPEG parsing, they can't do anything with it. JPEG deck. Safe mode API. Safe mode API is actually really cool. Safe mode is just this one process that doesn't host any commands. It initializes the screen. It's fully documented on the wiki. It's just a process. It's what runs if you like hold down a certain number of button combinations. Online save cloud. So, little tip about online save cloud, and I hesitate to say this because, you know, it's Nintendo's watching this, I'm sure. But I'm going to say it anyway, because they're probably not going to change the API too much. Online save cloud still has all runtime type information included. They started removing runtime type information in 4.0, but online save cloud still has all of the RTTI that used to be in pre-4.0 system modules in it, even on latest. So it's great for reversing because you can get all of your like real shit. Also, sorry if you hear like trains in the background. I live kind of near a railroad track, and so you might hear like train noises. But yeah, when they made OLSC, they forgot to turn off RTTI the way they did in 4.0, and so. Oh yeah, no, it's great. I'm next to a railway, but I'm also like right next to a beach. It is like a 45-second walk from where I live to a beach, and the rent is super offset by the railroad, and I live in a great location. I am very happy with where I live. It makes life next to the beach affordable, which is like more than I could ask for. But yeah, this is a super meme system module because of all the RTTI. You can reverse it very readily. It's mostly just talking to like the FS commands that wrap the like cloud save transformers anyway. Look into it if you're interested in stuff. It's a little complicated because it does a lot of FS indirection, but it's not hard. These two aren't real. They don't exist. They're not in dev firmware yet. Frikin says Cyrus is actually homeless and is trying to seem like he's not. Oh, you got me. I'm secretly homeless, which is how I'm streaming this with good consumer internet. You got me. I'm caught. Oh no, my secret revealed. Pirating fiber. Yeah, clearly. But yeah, that is all the system modules. The kernel is fully reversed as of 6.0.0. Let me actually just demonstrate that really quickly. Downloads kernel 6. This is Tux's database, which is just incredible, and I use it all of the time. Breakpoint format is newer than expected. Cannot restore it. Yeah, whatever. I don't need newer breakpoint formats. Yeah, so Tux labeled every function and labeled every bit of data. The kernel is definitely well understood. I mean, Mesosphere is a thing that I am planning on working on. Yeah, we understand the kernel. I want to re-implement the kernel. Kernel implementation is happening. We understand it. That's all there really is to say on the matter, I think. Yeah. Totally understood. I mean, I understand the IPC stuff really, really well, and Tux understands the scheduler stuff better than I do. But Like, we have a really, really good kernel AV. This is all Tux's work, and it's all incredible. It is all so incredible. Yeah. Yeah. That's all there really is to say on that matter. And obviously, you guys saw me fully label a secure monitor recently. So, obviously, the secure monitor is understood. And Fuse implements all of the stuff that's in NX bootloader. Although I don't think anyone ever diffs NX bootloader. I could not give less of a shit about what NX bootloader does apart from the hardware initialization. So I don't think anyone really understands NX bootloader, but it was reversed well enough to implement Fuse. So yeah, that is an overview of all of the stuff that isn't reversed on the Switch, and I hope that answers your question. That was a lot more detailed than I was expecting to go into, but it was probably, hopefully, interesting. So yeah, let's hope that was good. Let's get back to working on the SD card logger. So we had reversed all of this stuff, but we hadn't reversed make log file path. We know that once it makes the log file path, it opens the path, and then it writes a header to it, which is this magic and this version number. So let's see, how is it making this path? Oh, and it's also setting this to 8. So I'm going to go ahead and say that this is a log file offset, which makes sense because this is just written 8 bytes of data. Yeah, so it gets the current time. It converts the time to calendar time in UTC. Calls something. It gets the serial number. Okay. Get serial number. This definitely takes in, like, keyword. This definitely takes in a keyword. Yep. That all tracks. I'm playing Fire Emblem, whatever the one after Fates is. Okay. As someone who is very deeply emotionally invested in Fire Emblem and really likes Fire Emblem games, let me correct you because you're wrong. Fire Emblem released Awakening on the 3DS in like 2013-ish, and then it released Fates, which I still think of as IF because they did the big translation project after that. Then after IF, they released Echoes, which was a remake of Fire Emblem 2 Gaiden, and they called it Echoes Shadows of Valencia. And then they released Three Houses like a month ago, like 3 weeks ago. Three Houses is an incredible game. I have wasted so much time playing it, and I don't really play games a lot, but Three Houses is excellent. It's a great Fire Emblem game. It's very easy, but it's a great game. Hedrick says, wait, I thought Awakening came after Fates? No, Awakening came before Fates. Fates was the one that came after Awakening. Noir Skip says Three Houses is going to be my first one. Really good choice. Three Houses is not as hard as the others. Even if you're playing on like hard and classic, it is just not that hard. And it has amazing gameplay, it has amazing story, it has amazing characters. It's a great entry point. I would like play it on like normal, and then if that's like normal and classic, don't play casual. Casual is for plebes. Anyone who plays on casual needs to get out of my house. But definitely try it on normal. That'll be super easy, and then when you realize that it's super easy, move it up to hard. There are 2 other difficulties, Maddening and Infernal, in the code. Maddening, they're saying they're going to release in an update, but it's actually fully complete on disk right now. I've done 3 of the 4 routes so far. I played 1 on normal, 1 on hard, and 1 on Maddening. Maddening is actually really fun. It's harder than hard, but not much harder than hard. It's complete on disk. I don't know why they haven't released it yet. As far as I could tell, there was nothing like bad about it. And Infernal is just clearly incomplete because the enemies on the first map are level 99, and that just seems like they haven't finished it yet. But if you want to play Maddening, you can just edit your difficulty in your save. It's trivial, and then you can play the content that's already on disk that they haven't released yet, that they're going to release in a quote-unquote free update. Definitely do that. Maddening is great. Anyway, back to SD card logging. It gets the current time, it gets the current serial number, and then it prints SD card, / and then the directory. Oh yeah, you are definitely coming in on a high note. It's a great series. This is the output directory. I'll just call it directory. This is the out path, and this is max size. Great, it prints SD card colon slash in the directory, and then the like user path, I guess. And oh no, wait, it's a user directory serial number, and then like this timestamp in this UTC calendar time format. Okay. V7 is 1. Plus plus is less than 100. Okay. 402 already exists. This is like an index. It looks like if index is 1, which is true the first time we're in the loop, it just does path.nxbinlog, which makes sense. It's in switch binary log. However, if it fails, this is probably going to try to create the file. Create file? Yep, create file. So it'll create the file. Create file only takes 2 arguments. We don't need these. That's like a create mode. 0 is the only one that we care about. If this was like 0x8000, it would make a big folder file, but it's not. If it succeeded, we're done. However, if it already exists and I is less than 100, then we continue. Other failures will just return. We'll return failure. And so it looks like this will try to create the file.binlog, and then it will support up to 99 ones with the same, up to 99 other logs with the same serial number and timestamp. So this looks like redundancy so that they don't fail to have a unique log file for the current boot. That all makes sense. Okay. Open file, write this header to it, close it. That makes sense. Yeah, okay. So, V8 is the current offset. That makes sense because it's being passed to write file. Offset, this is data. This is data size. This is like num actually written or something. Hedgeberg says, wait, how does playing on Classic not give you crippling anxiety? Do you want the honest answer to that? I mean, the joke answer is get good, don't be a plebeian. But the real answer is the games since Echoes have introduced, in Echoes it was called Milo's Turn Wheel, and in Three Houses it's called Divine Pulse, where some number of times per battle you can rewind to a previous turn. And I try not to use Divine Pulse because it's cheating, but assuming there is no reason not to play on Classic, because if your character dies, you can just rewind the battle, and it encourages you to learn how to play the game well enough to not have units die. I feel like you gain a lot more playing on Classic and rewinding if you're going to let your units always survive, and learning how to play in ways so that your units don't die, instead of just not facing any consequences for unit death. It's an objectively superior mode. I mean, I understand why you would play on a casual, because you are a casual, but as someone who is not a casual and likes tactics games, yeah. Anyway, so it'll try to initialize, it'll open the file, it'll write, it'll close. And if it succeeded, then it will set the log file offset to log file offset plus the amount that we wrote. It's not actually checking them actually written, but this also doesn't matter because this is never anything other than what it was actually written in practice. As Rick says, I love tactics games, but character-based tactics wreck me. I hate losing my characters. Yeah, that's fair. Just play better, or use the mindless turn wheel, or use Divine Pulse, or whatever it's called. I do think that having the incentive to make sure that you don't let characters die is worthwhile. Like, I would honestly tell you, you are better off playing on Classic and restarting your system when characters die than playing on Casual. I understand why you want Casual, and, you know, you do that on Casual. Why are you playing on Casual? If you are going to reset, there is no difference between Casual and Classic. Yeah, fair enough. I'm not you. I can't judge you. You know, whatever makes you happiest to play the game. Anyway, this, if it is initialized, which it must be because we're in here, then it will just return success here. Otherwise, we are somehow uninitialized, but we actually wrote. I don't know how that could possibly happen. Maybe if there's some kind of concurrent access going on, because it's not acquiring a lock. Yeah, it doesn't have a lock, so maybe it fails to initialize somewhere in here, and this is like some threading handle. So if we fail to initialize and the SD card is mounted, oh boy, it's acting as a word. That's really gross. That's really gross. Local types. What is that? What is the upper byte there? Is SD card mounted? Some other bool. Some other bool gets set to 1. Is SD card mounted? Gets set to 0. So that does something. That definitely does something. Anyway, if it's initialized, this initialized, it sets it to uninitialized. It locks a mutex, and if there is a function, it calls the function. Uninitialize function. Let's call it that. That's probably what that is. Yeah. If the uninitialized function exists, it calls it on this. Or it calls it... Oh, wait, no, this is probably a set initialized function. I'm going to bet that this... Because it's calling it with v10, so it's probably going to, like, set whether or not we're enabled. Yeah, it might be this ready, this available. I like initialize because they're all the same concept. Yeah, that's what that probably is. Log. Is there something in here that would have set that function? Oh, no, wait, wrong thing. Get SD card logger. It's 0 initially. It might be set elsewhere. Has progressed to get her charger, so she'll be back. Great. Well, not great, but fine. Okay, so that I am confident with how well we understand this log function, or this flush function rather. This is definitely a flush. This is definitely a flush. So we can remove the maybe from the name. Well, might not be a flush actually. It's in send log packet impl, and it's just okay. Yeah, it's probably, this is probably some threaded, this is called by some thread probably. We will reverse how this gets called when we actually look at the threads that were created in main. Like, I am entirely sure that that flush thread that we looked at earlier and haven't actually done any reversing work for is going to be managing this. That's got to be right. But okay. Logger, log impl. So now we know what all of this does. Log to getter service. Log getter service flush maybe. So we know that this is controlled by the start logging and stop logging functionality of the log getter object. So let's see what this actually does. Okay, this is calling a bunch of stuff. It's doing a whole bunch of things. That's fine, we'll figure it out. we will figure it out just fine. This head, this is a log packet header. It looks like it's doing some kind of parsing of the packet. This is probably like packet parsing in order to log stuff out to user log. But let's not assume anything. What is A1? Packet header. Yep, packet header, data size. This is actually just the packet in general, not the packet header, but that should be fine. Packet header, data size, flush maybe, and 0. Okay. Packet. Packet size. Let's call this maybe flush function. This is known 0. Is v4 ever changed? No, it's just passed, so we can alias it. Is this ever changed? No, so we can alias it. Is this ever changed? No, so we can alias it. We probably don't want to alias this. We'll just call it packet header. What does this do? Gets the process header, or process ID, log packet header, get process ID. It's not, okay, so let's call this g log getter process ID. Where's the set? It is set in the same function. Okay, that's fine. If it's a header or the process ID is not the same, 0 is head. If it's not head, then we return false. Okay, so if the process ID doesn't match, then we have to return false. If it's a head packet. The process ID is allowed to not match if it's not a head packet. What's this doing? Thread ID, okay. G log getter thread ID. Let's call this current. It's probably changed. It's fine. This is going to be log packet header get thread ID. Okay. If the thread ID doesn't match and we are not head, then we fail. Okay. That makes sense. This is the same thing here. If it is not a head packet, then the process ID and the thread ID must match. But if it is a head packet, then it's fine. That's the thing it's logging? Yeah, that is the thing that it's logging. I know for a fact that this gets overridden, this process ID gets overridden by the log thing. It gets set to whatever the process ID was used to open the logger. So that should theoretically never be wrong. Let's see. Some kind of global. It's validating this is correct. V8 has to be true here anyway, or else we wouldn't have gotten here, so that's entirely fine. Packet header +1. So this is going to be the data after the header. Data after header. And this is some kind of remaining size. V8 is just like a, are we valid? Valid. If we're valid and this is not equal to 0, remaining size is greater than or equal to this, then remaining size equals this. Okay. So this is definitely going to be some kind of G, like log getter buffer size. That makes a lot of sense to me. If we're valid and the amount of size in the buffer is not 0, remaining size is greater than that, remaining size equals that. Otherwise, remaining size is the packet size minus the header size. That makes sense. And if this is a thing, then we call the flush function. And v10 is the buffer remaining size. That makes sense. v10 is the amount that we want to Yeah, okay. That totally makes sense. And this looks significantly more complicated. So let's say that it didn't manage to flush all of the data, since I assume this is some kind of flusher. G log getter can flush. Maybe. If remaining size is 0, since it's the keyword, then we set these variables to 0. Otherwise, 16 is data after header less remaining size. So this is like a data end, because data after header is actually like really current data pointer, since it gets updated after we try to log. That's interesting in that the current data pointer and remaining size will be updated even if we don't actually flush anything. So that's unfortunate. I guess that if we don't flush, then that data just gets dropped. Getter can send data. Nah, flush is better. Let's call it flush. Oh boy. V19 is the at current data pointer process ID plus 2. So current data pointer is no longer actually a... Oh wait, this is at now. This is just current data pointer plus OX10. This is not the right type, so it's just doing stuff weirdly. Plus OX10. V17 plus 7 is less than OX40. V17 is initially 0, so it's definitely less than OX40. This is, yeah, keyword. Okay. V18 or equals... I need to undefine this type, because this is just a void star at this point. Current data pointer at 7F. Shift left by this. Okay. This is some kind of packet parsing. This is definitely some kind of packet parsing. It's going to call flush here, so the data will eventually get flushed anyway. Current data pointer gets 1 added to it. I am going to assume that this is some kind of text format. This is parsing some kind of data in some kind of new format that we haven't looked at all yet. So let's actually turn all of this stuff on the stack into like a reasonable variable that we can work with. V14 is initially 0, V15 is initially 0, V14 gets set to V18 equals 2, V15 gets set equal to V21 minus V23. That looks like a size minus another size. It's probably some kind of a remaining size to like add to the next thing. Data end is clearly the current end of the data that we're parsing. Oh, is it a enum? Excellent, thank you. Thank you very much. What are the types here? V14 is a bool. V15 is int64. Okay. V17, what is V17? V17 plus equals 7. That might be like a current pointer or something. Maybe. I'm not entirely sure. And then V18 is some kind of like control data. Instances might be log packet chunks. Oh, this probably is log packet chunks. Do we have any structures for log packet chunks? If we do, that would be awesome. Yeah, this is almost certainly related to push data chunk. I'm like sure this is the same kind of parsing that push data chunk is doing. Yeah, this is like is text log, if that's the enum value that Masan said. Okay, well, in the meantime, while you look for that, I will look at what this flush function does, because we have the flush function that's passed as an argument here. This is getting some global object. Get global log getter object. What is this doing? It's like a constructor. Interesting. Interesting. I think that this is like a thread creator, maybe. I'm not entirely sure, but I think this is probably some kind of a thread creator. What does this do? It memory copies to, okay, let me actually make the structure. Oh no, it's probably not a structure, it's probably not a thread. Struct global log getter object. I think it's 4 keywords, I think. No structure push data chunk. That's fine. We'll deal with it. We'll deal with it. Let's say this is log getter object. A2, A3, 10 is 0. This is A4. So this is some kind of function. And what are A2 and A3? A2 is this. This is probably a buffer and a size. Size, this is probably a flush function. Great, okay. Let's actually just make this a log getter object. Did I not name the buffer and buffer size? Because I swear 8 was the buffer size object. Oh, yeah, I didn't name them. Buffer size. Okay, and if that's that, this is definitely an offset. This is buffer. This is a size. If size, yep, size minus offset, yep. This copies data into this global buffer. That totally all makes sense. And if it fails, then this is a g global log getter dropped packet. Okay. That totally makes sense to me. Because if it doesn't succeed here in copying it into this global buffer, then it just fails. And I bet that if we go to log getter get log, get global log getter object, yep. 5, 4, A3. Yep, flush function. Okay. What is that flush function? It just sets globals, if I remember right. Also, it took like 2 arguments, so let me actually keyword flush function keyword. Do I have to edit it in the local types display? I might. That's definitely fine. So why is this not a... it's because it's casting it to something. Right, here's how you do this. Edit, other, decompile is call. All right, I need to make it not a function pointer for this. Edit other. Oh wait, actually there should be something here. Force call type. Yeah, that'll work too. I also would actually might take one more argument, but let's go back to that flush function. Log getter object flush maybe. So this is G global log getter buffer. This is G global log getter. It's probably a size. I'm almost entirely certain that it's a size. I know it's an offset. Oh, but that is a size because the offset is the amount of size that there is to actually read. Flush global log getter info, and this is probably going to like copy it to output. This is probably like an output buffer and an output size, probably. If global log getter buffer is greater than this, what is A2? A2 is. Does this take multiple arguments? Not sure what these arguments are. Get back to log services, not documented figures. Okay, well it doesn't really matter at this point. We can figure that out later. But yes, A2 and A3 are going to be the pointer and size. That's the buffer init size. So let's say that's the out buffer. Out buffer size. This is out buffer. Out buffer size. For out packet drop count. Yep, that makes sense. So what this is doing is it's just gonna copy into the output buffer as much as it can, and then it's gonna save the amount of packets that have been dropped so that that can be known, so that people who are using this API know when they are losing packets. Yeah, this is out drop count. That makes sense. That absolutely makes sense. Next, this is taking out copy result. Oh, this is probably out is success. Out is success. And out packet drop count. That makes sense. Okay, so this function takes in an output buffer, a boolean to output whether or not it succeeded in getting information, and a boolean and an output pointer to write a number of dropped packets to. So that all absolutely makes sense to me. And this is this packet parsing stuff that does complicated logic for parsing, I assume, text out of these packets. It might be doing something else, but that's what I think this is doing. We probably want a struct for this more than anything at the moment. So let's call this is probably just an implementation of parse data chunk. Do I have parse data chunk labeled? No, I don't. Ooh, Masan says that they think they have some idea of what all this is. Masan says they have this Uleb 128 type, which is an integer encoded in a variable number of bytes, where each byte uses the high bit to indicate whether another one follows. Okay, I absolutely believe that. That all sounds super believable to me. I think you're probably right that this is going to be one of these ULEB types that you've described, followed by something else. It's actually, it looks like it's two of them from what I'm seeing here, because there's one of these and one of these. Yep, ULEB 128 key, ULEB 128 size, data. So it's not really possible to make a good struct for, is it? That seems hard to make a good struct for if it's like a variable number of bytes. Let's think about this for a second. Just calling something. Okay. It is. This is less of a flush, to be honest, and more of a like a process data kind of a function. And it's going to be taking in v19, which is a pointer to the current thing that it's processing. Probably this is going to be the size of what it's processing, and some kind of argument, I guess. It looks like this is always unconditionally 0, so we don't need to care about this third argument yet. But it's some kind of an argument. Okay, so let's think about this. Oh, Misan, is there a maximum number of bytes in which a ULAB can be encoded? Is a ULAB 128 like 8 bytes or is it 16 bytes? It's probably 16 bytes because it's adding OX10 here. However, it's also doing like -1 stuff here, and that's not immediately obvious to me what that's doing. Makes sense in theory, but I see them passing around in 32-bit registers. Okay, I mean, this is clearly... V18 is going to be the size of the current like data chunk, right? And it's getting ORed in bytes over and over. And if it doesn't have add OX80, then it's done parsing the size and it continues, but otherwise it increments the data pointer by 1, it increments this by 1, and it adds 7 to V17. And it's again not obvious to me what V17 is. Oh, it's the number to shift by. That makes sense. Okay, I see that. Got it. What is the like stack location of all this? Okay, it's not on the stack. Great. V18 is some kind of a data size. Not really. Let's call it ULAB data size. V17 is ULAB current shift. V14 is text log, and V15 is. Gets at the V21 minus V23. What is V? This is some other size that's going to parse out. If this, okay, this is, it parses ULAB 128 key, ULAB 128 size, okay. ULAB key shift, ULAB key size. This is going to be data size, data shift. And it is going to continue incrementing this, shifting until it gets the right size. V19. If V19 is less than data end, great. That's what it does there. V14, it errors out if it runs out of space and just drops the packet. If it can log stuff, this is like a number of remaining bytes for the actual data. Log data size. Seems like cur pointer. This text log, V15 is data size is this. Maybe data size is bigger than this. Then V15 is the difference between them. Interesting. VData actual diff. If the key size is 2, which is what we expect here, I guess. If the size is less than or equal to log data size, V24 is going to be data size. Okay, so it's going to log actual log size. It's going to log the actual minimum of the described data size in the header and the size remaining. In the current data pointer, it is going to increment by Uleb data size, whether or not this is actually correct. So that's interesting. So, is it just me? Feel free to point out that I'm wrong here. Or is it deserializing this size from the buffer and then adding it to the current data pointer without... Oh, I guess it does bounce check here, so that's fine. That's still... I know this is just a relic of inlining, but that's really gross. This must be like a bunch of stuff inlined at once. I don't think the key actually gets used. Oh, I guess this is actually probably the... this is probably not the key. No, this is the key. I have no idea what this is. It looks like it's just reading a little bit of metadata from it. I think to really understand this, we're going to have to look at code that actually generates these logs so that we can see what it's writing to the packet. Oh, you're right. Really be key. Okay, I believe that. Okay. Key is 2, and if the key is 2, okay, so this is text log. Probably. Yeah, okay. That absolutely makes sense. This is just the, do I have the enum in here? I thought I added the enum, didn't I? Let's go by ordinal. Log data chunk key. Now, what does it mean nothing contains 2? Anyway, this is a log data chunk key text log, so that makes sense. Okay. Synchronized IDB. Yes. That's dumb. That's really annoying. Yeah, there we go. Thank you for that. Okay, so that all makes sense. This will, if this is set, then it will log all of the data that it can. And if it's not set, or well, even if it's not set, it'll call this. Even if it is set, it'll call this. It'll then parse these and log anything that is text. So this will log anything that is text to this buffer that a user can retrieve later. So that all ends up making sense. Cool. I think we understand all of this at this point. We need to look at what the threads that are like receiving data for Target Manager and SD card are doing, and we need to look at what the like threads that initialize stuff are doing. But I think we understand how packets get logged. That all tracks. Which is great. Okay. I'm happy that we feel like we understand that. This, I definitely think we looked through log with flush. Yeah, we did. Is there anything else in here that I'm forgetting that we like said we'd look at later and then haven't looked at yet? It's definitely possible. Cool. I feel pretty good about the extent to which we have labeled the service functions. So what remains is for us to look at the initialization code that we said we would do later. Initialize the multi-session. Yeah, this just makes it do thread stuff. Okay, so it looks like it does global initialization on the Target Manager logger here, which is fine. And then it calls something on the Target Manager logger. Which, yep, that makes sense. It's got this host target connection system stuff that is taking in stuff from the Target Manager logger. Where is my Target Manager logger struct? Okay, well, it does in fact look like it's creating a thread at OX1000. to store this buffer with size 1000 and priority 10. Okay, that all makes sense. Clear event, it's going to start this thread, which I guess is at plus 1000 from where stuff is. Passing in the thread as an argument, yep. P664 is 3, the process of thread state. Okay. This is a bunch of stuff for thread management that I don't really care how it works because I don't use any of Nintendo's wrappers here anyway. It's signaling a convar, but I think the convar is probably part of the thread since it's passing in something relative to the thread and not relative to the actual target manager logger object. Okay, that's all simple enough. The argument to this thread is going to be the target manager logger though. So let's see. Target manager logger. So what does it actually do? It gets the working memory size. If there's too much of the working memory size, it'll abort. Virtual socket collection, 1 of 4 times. Okay. Makes sense. This is probably like a number of sockets. This is how much memory it has. Okay. I believe that. Where's the xref? Only here. Create Htcs manager by HIPC. So this is where it's actually talking to HTCS and doing like the service initialization for HTCS. HTCS service initialization. And what is this doing? Oh boy. Okay. So this is going to be the actual place where it is hosting it on the PC. I mentioned earlier that host target connection sockets lets you host a service at some name on your PC. So this is going to be hosting the service IYWYS at $LogManage, and then this is an R, at LogManager. Yep, that totally tracks. What is this doing? This is calling an HTTPS service function, which is going to be like getting a socket variable. HTTPS get socket probably. Yep, that all makes sense to me. Actually, no. This is probably not the socket, because socket doesn't take any arguments. I know HTTPS socket doesn't take any arguments. Yeah, that's probably fine. Not sure why it's not like writing the output of this to something, because it's definitely returning a value, but there's nothing I can really do there. Even if I make it and take it in another argument, it doesn't look like it's doing anything interesting. Okay. What is 112? Let's see if we can just figure that out really quickly. No way this works. Yeah, figures. HTCS. Okay. So 112 is it's probably a standard layout virtual table. 112 is 0x70. 0x70, there's 20 usually that's reserved for service objects that every service object shares. 8. Okay, that's not what I wanted to do at all. Thanks, Google. 0x70, 20, or 8, fine. 0x50 over 8, that's 10. That'll be service command like 10-ish. Get pure name any. Okay. This is going to be HTTPS get pure name any. Secpixel recommends Windows Calc, and I have still never used Windows Calc, but that's fine. We don't need Windows Calc. We have evolved beyond Windows Calc. Yeah, it looks like this is, I'm sure this is actually getting into the stack and we're just not seeing it. It looks like this is like a socket address with where it should host and what the peer name is. Cool, so it's gonna call socket. And if it's not zero, if it's greater than 0, it's like a socket file number. So it's gonna be socket fd is equal to v5, and that's socket fd. If bind, okay, so this is gonna be Htcs bind socket. Gonna bind the socket to v19 is gonna be all of this shit. This is like the stack structure for what peer name to bind it to, so that makes sense. And then it's going to call listen. That all makes sense. Okay. So we call bind and we call listen, and we want them both to succeed and return 0. And when the scope exits, we're going to close the socket descriptor so that we never actually do this. And it looks like it's storing this in atomic, so this is another atomic in 0 in this logger. It's storing 0 in the first atomic int. It's locking the first mutex. And then it is getting some variable from the, this is probably a callback. This is probably like a on logging callback. And if there is a callback, it gets called with 1 here. And then we unlock. Then we unlock the first mutex, and we wait on the, or we signal the conn var. Because this is 1D is signal process wait key atomic. Yeah, signal process wait key. I don't know why there are 2 instances of that, but that's fine. Doesn't really matter. Also, this returns a result, but it doesn't look like it's using it. Anonymous says, watching this makes me feel like my comp sci degree is worth about $5. I'm sure that your comp sci degree is worth significantly more than $5. I have spent a lot of time reversing Horizon system modules, and so I take a lot of things for granted because I can just guess what things are doing, and I am usually correct about this, which is amusing on its own. This is, what is this? Fetch receive. Okay, so this is doing a receive. ACCS receive. It's receiving 1 byte, it looks like, from here. And I bet that this V9 is V8. Yeah, okay. Yeah, okay, so this is, what this is doing is it's waiting for there to be stuff to do. It's locking, it's calling a callback saying we're starting a log. We signal to the other thread that go ahead, send your data. And then we receive a byte at a time while we can. And then we close the socket. This is a client socket because we're accepting. Client socket FD. We receive as many as we can, we close it, and we lock. And that all makes sense. And then we wait for up to another second for another event. And it looks to me like this isn't a thread, so it looks to me like this needs to be receiving something every second, or else it will kill itself. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that's 1 second. So I guess that if it doesn't successfully get something logged every second, it will just commit Sudoku. So I don't know why it's doing that, but that's what it's doing. That seems like bad design. Why would you want it to kill itself? Does this ever get called again? This function will make a new thread and like do stuff, but that's only called by main. Jeez, that's not how I would do this. This, as soon as it fails to receive a packet in a second, it will stop receiving packets. That's super dumb. I mean, I get that in practice you probably have system modules logging stuff every second, but why not like go into a retry loop instead of just killing yourself? Okay, well, we understand how this works now. I feel like I no longer really have questions about how the target manager logging works. And if I go here, it's doing HTCS send versus HTCS receive, so that's exactly what we would expect. That is exactly what we would expect. So the data is getting sent to the PC here and received byte by byte. And the reason why this is doing this is because see how much time we have. We log the data. Yeah, that's all straightforward. And this is going to be like this socket descriptor number that I'm not going to label because I don't care about the details of HTCS at this point. Yeah. Awesome. Killing says comp degree is good for things it's focused on, which is robot creation from scratch, and not about destroying and picking apart the pieces. Caveat, Ketling hasn't finished his degree, and he doesn't know what the stuff other than C++ programming classes teaches. Yeah, I mean, I can't really comment on anyone's CS degree. I'm glad that you're having fun watching and following along. I mean, that is the hope. I hope that this is educational and that we are all learning how the LogManager works. I definitely feel like I have learned a lot about how the LogManager has worked in the last couple of hours. So, we've now looked at this target manager thread. Great. Great, great, great. What is this doing? This is creating this flush thread and clearing this event. Okay, so what does lm flush thread do? We know that there's no argument, which is the same priority as the other things. There's a stack of 0x2000 bytes, which is fine. Oh, actually, I absolutely know what's going on in this target manager logger. It had like a 1000 byte stack. Yeah. So the thing that's passed in here is the stack bottom right here and the stack size. So it looks like this target manager logger is actually passing in 0x1000 bytes for the stack, and then it's got a thread struct, and then it's got other stuff. So that makes sense. All types target manager logger. Where is that? Here it is. Byte, thread, stack, 0x1000. I don't remember the address of this convar. Now is when you actually use the structure view. Stuff should be synchronized in here. It looks like it's not really wanting to show me this stuff. Target manager logger, control numpad to expand. Convar is at 11CO. Okay. Byte, thread, struct, 1CO. That makes sense. Yep, that is absolutely what's going on here. Okay. So what does flush thread do? What is this? Sets a global to 0. G set to 0 by flush thread start. This is almost certainly creating a heap. Yep. Create linear heap. So this creates a new heap located here so that we can do allocations. It's going to reserve 0x8000 bytes of memory for allocations related to this flush thread. And if it doesn't succeed in creating the heap, it'll abort, which makes sense. Then it's going to set the allocator functions for FS to use this heap, I'm sure. Yeah, that's basically what I would expect. It's going to be flush thread alloc, flush thread free. And now when the file system library needs to do allocations, it will only use this heap. Okay, this is calling other stuff. So what is going on in here? Oh, wait. Xref this. Yep, okay. This should abort on failure. File system library supports this feature for aborting on failure based on like a user configurable rule. So this is just making so that FS won't abort if it fails to do something. Yeah, okay. Set allocator. This is probably, what's this gonna do? Interesting. Shared memory. This is probably more file system initialization. Oh, hey, Hedge, you're back. You missed a bunch of stuff. We labeled all of the like target manager thread function initialization. We finished labeling all of the packet parsing, and now we are looking at the thread that actually manages flushing. Okay. Time you. Okay, I know what this is. We don't care about this. This is a NN time initialize. And it passes like 1 to some like helper. And 1 means it's going to be using time u. This is using a user mode time services. It's locking this mutex. This is probably like creating a wait holder. Yeah, this is multi-wait holder of event, which I guess I don't really care particularly much about. It's opening an SD card detection event notifier. It's getting whether or not the SD card is a thing that exists. Okay, it gets the SD card logger. Hedgeberg says to Anonymous, your degree gives you a solid set of fundamentals that make picking up things easier. Even if people get the least of the degree, you usually get that. It's important. You don't need to get a degree for that, but it helps some people a lot. I think I agree with what Hedgeberg is saying. I think I absolutely agree. So what is this? SD card logger. Set initialized function equals v2. Okay, so that's where the initialized function comes from. SD card logger set initialized function. And this probably takes in a Boolean, I think. Okay. Oh wait, it needs to be type bool, not name bool. Bool initialized. Okay. If we're setting it to initialized, then it signals an event and it's done. Otherwise, it clears the event. It tries to wait for a different event. GSD card logger ready event. This is probably GSD card detection event. And if it doesn't succeed, then it's setting some bool to this. This is just tracking whether or not the SD card is like inserted and ready for doing things. So there's nothing particularly interesting here, but good to know. Yep. Locks mutex, sets the function. Totally tracks. Yep, multi-link wait holder of event. It's linking these. G flush events multi wait holder. Okay. I'm just getting the target manager logger, and it's setting. Okay, this is definitely going to be the function that's like in the target manager logger that we were looking at earlier. Target manager logger. This is the on logging callback. Target manager logger. On log callback. Oh, okay. I guess this is not just a SD card event. This is probably a G on logging event. G on logging ready event. Okay, I believe this. I believe this. Okay. And it's again linking this event to the multi-link wait holder. Hedge says one of the big problems in education is that learning sources, like people just streaming what they're doing, is super underrated as a way to learn. That's why Hedgeberg used to do this stuff, and why she's glad that I'm doing this now, and why she wants to get back to it eventually. Yeah, that's super. I am happy that people are learning things from this if they are. I hope that they are. Adams asks, what exactly is a multi-weight holder? So if you look at libstratosphere, I cheated with Waitable Manager. Waitable Manager has 0 equivalent to anything in Nintendo's library. Multi-link wait holders, they basically, any waitable object has a holder equivalent. There is holder of event, holder of process, holder of inter-process event, holder of interrupt event. Anything that can be waited on has a holder object, and there are like 12 of these. And a multi-wait holder holds these intrusive lists inside of the actual holder objects. And so a multi-link wait holder contains a list of holder objects for things that are waitable. And a multi-link wait holder lets you wait on arbitrary waitable objects by linking them to this holder. It's Nintendo's way of getting around a lot of bad things about C++. Cool, so this does flush thread initialization, which makes sense. Then it gets this unknown global object 1, and this just looks like it's waiting for there to be something to flush. And then it gets the second object, and okay, yep, this calls flush. It looks like this is wait for there to be something to flush, and then flush it. And then in a loop, wait for any of these like flushing events, see which flushing event there is. If it's the target manager one, continue. Otherwise, clear the SD card detection events because that's what we waited on. And then check if the SD card is inserted. That all makes sense. This basically just says, once we have logged something, see which of the things we logged to. If it's the SD card event, check if the SD card is still inserted. And this we don't care about. This is all finalization code, which we just don't need to give a shit about. So the flush thread is, at its core, going to be really simple. It does all this initialization to set up these events that it can wait on. It waits to be signaled that something can be logged, and then it flushes, which makes sense. It calls this send log packets function. Cool. That was much simpler than anticipated. Are there any other threads? No, this is IPC code. Okay, I guess we have actually looked at everything that we care about. We haven't really gone into the depths of NNLM detail, but that is client code in the SDK, so I'm not sure how much we care about it. Because we can probably just infer how it works. We should check it in case there's like anything super critical in there. So I guess I will, but I'm not expecting anything crazy in it. Log packet transmitter. We looked at all of this earlier, actually. Push log packet drop count. Yeah, that's what we would expect. Yep, this looks like the code that we were looking at earlier. I definitely think that's what this is. Okay. Yeah, actually there just isn't really anything to look at in here. We looked at all of this earlier, I suppose. Okay, that is everything that I would usually label if I was reversing a system module labeled, I think. 3 hours and 40 minutes. Man, I'm doing a really good job of having roughly 4 hours of content when I do the stream. The first time that I streamed, I just chatted for 4 hours. The next time, labeling trust zone took me about 4 hours, and it looks like it has taken about 4 hours to go through LogManager, which is great. That's a good length for a stream, I think. So I'll probably stick around for like another 20 minutes so people can ask me questions and chat about LogManager or anything else on the Switch. Yeah, I hope this has been interesting, and I hope this has been fun. My hope is that we can do like a series of these where, now that I've reversed LogManager, I can go through the process of implementing LogManager on stream for Atmosphere. And the target manager stuff, Atmosphere doesn't have target manager yet, so I can't really do that yet. But I can do all of the SD card logging stuff, and I can do the like custom log buffer stuff. And if I do those, system modules can use those games log stuff to LogManager when it exists. We can like have like a custom setting, Atmosphere enable LogManager, that lets you not pay runtime costs if you don't want to get logs. We can have fun implementing this in C++ for Atmosphere, I think. It is a small system module. There's not a ton of logic to it. We feel like we understand it. Yeah. So is there anything LogManager related or Switch related in general that people are interested in chatting about for the next 20 or so minutes? I'm going to spend the next like 30 seconds checking if anyone has messaged me something on Discord in the last 4 hours, which probably they have. It doesn't look like there's actually anything super important in my Discord messages. Yeah, I have like a bunch of messages, but none of them look important. CompuCat says I should probably stop working and say hi. Hi, CompuCat. I hope you've been enjoying the stream. And hi to you too, Destiny. I really hope you guys have enjoyed watching this. I hope that watching the process of reverse engineering a system module has been interesting. I mean, I hope that you've learned that it is not like I just know what to label everything. It's a lot of guesswork, it's a lot of maybes, and it's a lot of just going through things step by step and trying to gain a better understanding. Concat says they're alright with dev work in the Wii U scene, but need to learn RE. Yeah, I super recommend learning RE. I love reverse engineering stuff. It's really fun. Hedgeberg says, to be fair, a lot of reverse engineering is getting used to what algorithms look like. Yes, that's very true. A lot of reverse engineering is having done enough reverse engineering in the past to just know by eye what's going on in the reverse engineering program interface. Okay, I remember when I didn't know what I was doing at all with IDA, and it was just impossible to get anything done, and then I gained a bunch of experience with IDA, and now I know all the shortcuts, I just label what I'm thinking, and it keeps getting better. Destiny says, do you mind if I ask? Not sure if it's been asked before, but how do you have information on dev-only system modules? Which system modules do you mean? I mean, obviously for like ones like LogManager, I just have the executables, but do you mean like the ones in the title list? I'm like happy to comment on stuff in the title list if that's what you mean, but I'm not sure what you mean by dev-only sys modules. Do you mean like how do we have the names for them? Because I know there are a bunch of titles where I was like, oh yeah, that's what this is, and said that we have never actually had a copy of it, which is also true. And so if that's your question, I can answer that, but I'm not sure if that's precisely your question. I mean, I know when I was going through this list, I was like, oh yeah, JIT. So there are two classes of system modules, Destiny, since you asked about JIT and Profiler. So there's like stuff like Profiler and JIT, where I just have the binaries for these, and so the reason why I know where they work is because I have reversed them in the past. And I mean, like, if you look at the npdm for this, if I go to hacktool, the npdm, main.npdm, The processes have names, like this is just LogManager, and so I know that they're called profiler, and I know that they are called JIT from the ones that I have the binaries. And then there is another class of stuff, like time, etc., where I don't have binaries for them, and I don't know if there have ever been binaries present. But there's a system title for devs called a dev menu app, something like that. And inside its ROM file system is this file called sdkprogramids.json. And sdkprogramids.json lists every title by its ID and name that Nintendo's build server knows how to build. And so that's how you get the names of like system archives, and that's how you get the names of like system titles. I'm sure it'll get fixed because I've mentioned it on this stream, but that's how that has happened. It doesn't really matter now since they're not really adding new titles at this day and age. But that's how dev unit only stuff really gets learned. Copycat says, stupid random question. If you're diving into reverse engineering with a bunch of unknown function prototypes, what clues you in as to what it's a data type and what's a pointer? StuckPixel says, generally IDO will generate a bunch of disgusting casts so we can dereference it if it's not marked properly. Yeah, that's very true. So, I'm going to answer this kind of weirdly, because if you spend enough time reverse engineering, and I don't know if this is true for Hedgeberg or StuckPixel, but I'd love if you guys could comment on this. I don't think of pointers and data types as being different. Everything is a quad word in my mind. Pointers and data are just not separate types. A pointer is a kind of data. Hedgeberg says that I'm used to ARM, which is true. I mean, I never do anything that isn't ARM. So I'm definitely biased in that regard. But my experience with ARM has just made me not treat pointers and data as different in the slightest. And so when I'm focused on trying to figure out a function prototype, I care more about the number of arguments being correct than I do about the types of the arguments. And then I can see how the code dereferences the arguments and uses the arguments, at which point you can see, if this gets dereferenced, it must be a pointer. If it doesn't get dereferenced, it's probably data. That's as good of a heuristic as you realistically need. And yeah, Hedge says, and I agree, that one thing you pick up really quickly is recognizing what is and isn't a memory access from a compiler. If you don't have a segment for whatever's being read and written, IDO will actually like go memory and then the address that it's reading and writing to, but most of the time it'll just show you what a loader store looks like. Oh, also, suggestions. So LogManager is fun, and LogManager is small, and I can re-implement it pretty readily, and I'll probably do a stream where I like implement LogManager, since that would probably be fun for people. Is there anything else that people would be interested in seeing reverse engineered on stream? Is there anything else that people would like to suggest that I do on stream? I asked in Reswitched when I was planning the stream whether people would rather see me stream reverse engineering for this, or like implementation for Atmosphere, refactoring, debug monitor. And people said they'd rather see reverse engineering, so that's what I did. But what kinds of things would people be interested in seeing me stream in the future? And Compucat says, are there any binaries in particular that are useful for learning to detect these patterns? Small binaries. The smaller the binary, the easier it is to reverse engineer. And so you start by reversing small programs that don't do complicated things, and you learn what those do. And you gain the skills in identifying what things do, and you just get better at complicated things. Also, yes, Compucat Hedgeberg recommends microcorruption, and I 100% recommend microcorruption. It's incredible. It's how I learned this kind of stuff when I was starting. Yeah, it has an amazing interface. Can't recommend it highly enough. I just posted a link to it in the chat. I think microcorruption is around the time when I started referring to exploits as memes. I don't think that I like called the hacking work that I do like memes before I did microcorruption, and afterwards I refer to stuff basically exclusively as memes. And so whether that is a positive review of microcorruption or a scathing disrecommendation is up to you. But microcorruption is what made me love memes. Microcorruption has nothing to do with memes, to be clear. It's just what made me love memes. Yeah, so the premise of microcorruption is that there's this MSP430 CPU, and they give you this description of this like hardware lock that uses the microcontroller that you're going to be hacking into. And microcorruption gives you this debug interface where you're allowed to, you see the code that runs on this like virtual lock, and they have this awesome debug interface where you get to step through on a simulated version of the lock that you're trying to hack into, and then when you think you've solved the level, you provide the input to like the real hardware lock, and you don't get to step through and debug. Hendrik says MSP430 decompilation is in Ghidra. Yeah, MSP430 decompilation would make a bunch of levels of microcorruption way too easy, like Hollywood in particular. Don't use decompilers for microcorruption. It will significantly lessen your experience. Gain the skills with understanding assembly first, and then shift to like decompiler only, the way that I mostly use the decompiler when I'm looking at system modules. It's more than that. I will aid in learning to read assembly. Microcorruption will aid in learning to reason about assembly. To like succeed in microcorruption, you learn how to think about what assembly programs are doing and reasoning about what the logic those programs are implementing. And so it's good for learning these skills of translating assembly into logic before you just start cheating and using a decompiler. Am I thinking of something other than Hollywood? Because if I remember how I solved Hollywood, I like made an offline version of the debugger, and then I just simulated it. And Hollywood is like self-decrypting or something, and so I just let it decrypt itself and then looked at that. Oh, I'm thinking of Chernobyl? Am I? I think you might be thinking of Chernobyl, and I was thinking of Hollywood. Because I'm definitely pretty sure Chernobyl is like the memory one, and Hollywood is the like crazy. There's no actual hack, it's just obfuscated as shit, and you need to figure out what it's doing. I'm gonna be honest, Chernobyl is like a comparable level of difficulty to some of the heap exploits that I've implemented on the Switch. Like the heap logic that you do there is the same every time you ever do a heap exploit. Psychosis says it's not obfuscated, but Hollywood is obfuscated. Hollywood is like a reverse engineering obfuscation challenge. Chernobyl is just memory management hacks. God, this reminds me, Hedgeberg, did you see the article the other day? It was in some PDF that got released of a bunch of like hacking tips for how to beat any crack me without having to do any reversing work. which was just incredible. It's such a clever idea that I wish I had thought of myself. It's awesome. So the idea is, how do you beat any crack me? First, you take a coverage-based fuzzer, and you just run it on the program. And if the coverage-based fuzzer works, the coverage-based fuzzer will probably just find you the flag. Because the coverage-based fuzzer will just keep finding inputs that get further and further into the program, because most crack me's will bail out early if they don't have the correct flag. And the other one is a side channel attack that is just incredibly clever, which is just mutate the inputs, run the program like 10 times, and count some metric, like how many instructions did it execute. And if you do that, the input that gets the most instructions is probably the one that has the correct bit of input, and then you mutate it further and further. And that's also super clever. And they suggest other side channels, like number of memory accesses, or whatever. You're going to tell me that I need to get this in-depth offline. There's a PDF that I can just link you to that describes this in more detail. And, like, actually works. I tested it. It worked on a crack me in a real CTF and got me a flag with 0 effort required. Okay, so you say there's a lot of problems there, but it works in practice, so... It works for CTF problems, but real problems fall flat. Maybe. I mean, for problems where you are... I'm talking specifically about crack me's. Like, I was saying this is a good tactic for crack me's. And for a crack me where the goal is to find an input that gives you the flag, where the input is the flag, it works perfectly. I agree that for real problems it won't work so well, but I was specifically talking about crack me's. Those two techniques do, in practice, from what I tried them on, seem to work really well for the typical crack me problem, which is just really cool on its own. I'm sure that you can't really explain in a Twitch chat. That's fine. We can talk about it later. Oh, are you saying that they're all just stochastic hill climbers, and this, if there's like some failure from going from step A to step B to step C, where step A to step B reduces the heuristic despite the total increase? Yeah, I mean, I hear you. For most crack me's, I think that stochastic hill climbing actually works fine. But I definitely agree with you that it's a problem for any problem that doesn't get solved by a stochastic hill climber. It's just I think that most problems do get solved by a stochastic hill climber in these circumstances. I mean, that's the side channel attack. That's the second half of it, where you just pick a heuristic, and one of those heuristics is probably climbable for a stochastic hill climber, which I definitely mispronounced right there, but it's fine. Okay, it has been also, yes, Hedgeberg is correct. To be clear, no one has solved coverage minimum. But it has been about 4 hours. If there are any more questions, I will totally answer them for like another couple minutes. Otherwise, I'm going to say end of stream because it's like 8 o'clock here, and I've been hacking away at this since like 4, and I have not had anything to eat since like 12, so I should probably eat something. So yeah, if there aren't any more questions, I'm going to end the stream and go get dinner. Okay, cool. This was fun. I will stream again sometime in the next week. I'm not sure what day. It might be a weekday. It might be a weekend again. I'd like to stream on a weekday if I can. And I'm not sure if I'll be doing more reverse engineering or like refactoring or re-implementing LogManager, but hopefully it'll be something interesting. Thanks for watching.